Okay, cool then. Everybody ready for class? All right, yay. All right, this is a lot fuller class than I was expecting. I normally teach about 10 people with these in-person classes, so please work with me today. As I will tell people, you know, the authority figure is still a human being too. And so this is a lot of people to deal with, especially for live work. So one of the big things, like with the Silicon Dojo program, one of the ideas is I did martial arts for many years. And one of the concepts in martial arts is that the students help each other. So with some of this stuff, if you guys can help each other, like if you can find out where they missed the comma, that will make all of our lives a lot easier. So just one of those things to try to help each other out. The other thing I will just say, especially with attendance, so we're doing attendance now because we have just such a miserable show up rate. And this is impressively good, but some of our events, we've got like a third of the people that actually RSVP show up. So I just need to know who's showing up and who's not. One of the things I will say is when I look at Meetup and it tells me why people are coming to these meetups, one of the prominent thing is networking. And so one of the things I'll just remind you is if you're here to network and you have some kind of weird name on your thing, if somebody meets you and they really like you and they're like, I need that person as my next CTO, and then they have no idea how to find you afterwards, that's not actually effective networking. So you're all adults, do whatever you want to do in life. But if you are here for networking, I would say at least put your first name and your last name as your display name on Meetup, just to make life easier for everybody. So that's what you can do. But anyways, okay, let's get into the class today. So a lot of new faces. How many people are new to these classes? Oh wow, there is a lot of new people here. Okay, so if you don't know who I am, as obnoxious as that is to say, I started doing technology education on YouTube in 2009. So I've been doing technology since 1996, started off in the Army, went to the corporate world, was a consultant, had my own business with employees. One thing led to another, started doing education videos back in 2009. One of the things that I found over the years is how many people I've helped. I literally was in the Roman Forum in Italy getting over a hangover. I was sitting there, and it's one of those things, you go to like Italy, you go to Europe, and you're trying to figure out which wall matters. Like you've got two walls that are just walls, let's be honest, but this wall, you know, is like, you know, the world changed because of this wall, and this wall is just a wall. So I'm sitting there looking at, trying to get over a hangover. Literally had a Pakistani couple come up to me from Pakistan, and we're like, oh my God, you're Eli, the computer guy. I'm like, what? And getting a picture taken in Italy from that. And I met people like literally all over the world that my education has helped. And so the idea is in 2009, or online education was not as prominent as it is now. Like the idea that you could start a startup company doing online education was like a new idea. You know, it's 2026 now, so that is in the past. One of the things I've noticed is whereas before we had a lot of in-person stuff, but the problem is learning those extra things was difficult. The issue that we're getting into now, especially after COVID, is everything has gone online, and now we have very little in-person stuff anymore. And so my idea here is basically, what if we take the lessons from the YouTube world and try to transition them into the physical world? And so that's where I talk about authorityless, gatekeeperless, free to end user, hands-on technology education that empowers you to do whatever the hell it is you want to do. Basically the idea, what if we just have education where you can just come, you show up, you learn, and then you go away and do whatever it is you want to do. And that's basically the concept of what we're doing here. I will say, as I talked about before, literally last class that I did last Wednesday, I'm trying to figure out the smallest barriers possible to make sure everybody actually shows up. It is free to the end user. We might start charging $1 for these day-long classes, just so people do have to swipe a credit card to prove that they want to come, because that's the whole question. I don't want people not to come because you can't afford it. On the other hand, I don't want 20 seats to be like, we've only got so many seats. So when people don't show up, that's also a problem. So we're going to start with the $1 for these things in the future, just so you know that's going to happen. Let's see here. So that's going to be the day-long classes. Just so you know, though, again, my goal is try to educate as many people as possible, make this as open as possible. So the evening class is on Wednesday. So next Wednesday, we're going to have a class on Introduction to Programming for AI. Basically, it's going to go over things like wireframes and pseudocode and a lot of stuff. One second. Oh, okay. You need to take yours. Yeah, we'll figure that out. Anyways, but the thing with that actually is cool is we've got in use of the bullpen downstairs. And so in the bullpen, we can support up to 100 people. And so that's one of the things with this is certain things like in-person classes, there's just only so many people I can deal with at a time. That's just fact. Whereas seminars, I can have 300 people, it doesn't matter. So that's where I'm trying to balance, that type of thing. Yep.
The question was, for content-wise, is that intro to API programming going to be different from what we're doing today with the API programming?
No. So this today is actually hands-on. You are all actually doing work today. What is going to be on Wednesday is more the concept of programming, what programming languages are, what frameworks are, things called wireframe, pseudocode, agile versus waterfall, project management. So it's more the concept of what you're doing with programming will be on Wednesday. Let's see here. And that's it. The only final thing, too, is we do have a pretty full class today. So there are no dumb questions, but there are off-topic ones. So that's... Again, afterwards or at break, I'm more than happy to answer any question you have about technology. But again, with classes, sometimes people get very interested. They're like, well, what about what Google is doing with quantum computers in space? You're like, that's great. We'll talk about that one later. But let's just stay to Python functions right now. OK, no questions there? Everybody good? Cool. OK, so let's start talking about Python today. So today's class is going to be Introduction to Python and AI Programming. So we're going to take you today everything through what the hell a variable is in Python. So that's the smallest object that you're going to use in the Python programming language, all the way up to using something called the Ollama framework that allows you to interact with these things called LLMs so that you can build small artificial intelligence projects. One of the big things, my big buzz phrase for Silicon Dojo right now is AI is hard, APIs are not. Here's the thing. Like a lot of people say, Eli, I'm not smart enough for artificial intelligence. And it's like, yeah, you're probably not going to get hired at OpenAI. Fair enough. Neither am I, frankly. Most people aren't, right? Those people are insane brainiacs. I've actually talked with people that work in that world, and apparently the young people there nowadays don't even drink alcohol anymore because it would kill too many of their brain cells. Why would you have fun when you can build LLMs? Anyways. But that's great. That is wonderful that they're willing to sacrifice their lives to give us really cool products. And the great thing is what we are going to be using is things called APIs in general. But basically, when you're using APIs or when you're using modules, basically you need 5 lines of code. Right? They spend $1 trillion and who knows how many man years building something. You use 5 lines of code and spend a fraction of a penny. That's how the real technology world works. And so that's why a lot of people think you have to be really smart to be in the technology world. And the reality is it isn't so. We are using tools that other really smart people created. As I say, you have to be precise, not smart, to be in this particular world. We are going to be using Ollama today. So for the AI component, so Ollama is an AI framework that you install locally on your computer, and this allows you to run any number of different LLMs or other models. So when we talk about a model, this is where we'll talk about things like GPT OSS is the open source model from OpenAI. We are going to be using what's called the Granite 4 model today. There's Llama models, there's Pi 3 models, a whole bunch of different models. There's like 1,000 different models out there, and they all do things their own way. We are going to be using the Granite 4 model today, the 1 billion parameter model, just because it's incredibly small and actually gives pretty good responses. So if you want to play with models when you go home, you can just download different models and play with them. The big thing is going to be the power of your computer. So the folks that are using my little demonstration computers over there, you guys don't even get to use the 1 billion parameter model today. You get to use the 350 million parameter model today, because that's about the only thing that'll run on those things. So when you're looking at these models, so this is a MacBook M2 Max from a couple years ago with 32 gigs of RAM. This thing will run the GPT OSS model actually pretty well, and that gives you some pretty good performance. But this is also like a $3,000 computer about 2 years ago. His thing that has like 128 gigs of RAM, he can run whatever the hell he wants, but he also paid the money to be able to do that. All the rest of you, you're going to have to figure out what works on your system. So basically, you download it, you install it, and you run, and you see what the response time looks like, and that's what you do. Let's see here. Beyond that, OK, so we're going to be learning the Python programming language today. So Python is a standard programming language for Silicon Dojo. You do have to understand I've done technology since 1996. I've learned more stacks than most people are ever going to learn in their lives and forgotten them. They are worthless at this point in time. I literally do not care about stacks. Use whatever the hell you want in life. The reason that Silicon Dojo uses Python as our core programming language is because it can do so many things, right? So anytime you're in the technology world, you have to be thinking about what problem are you trying to solve for. My problem here is education. I am trying to teach as many concepts as possible to you folks, and so basically Python allows me to teach a whole bunch of different concepts to you. If you're trying to create a front-end interface, go use JavaScript, but that's about what JavaScript is going to do for you. Python is great. It allows you to do everything from build simple scripts, to you can build web applications, to you can use artificial intelligence, you can build applications for mobile devices. It just gives you a tremendous amount of functionality. Is everything good? They're probably good over there. So basically the way I think about it with Python is it's a super glue programming language. One of the big drawbacks you're going to hear about Python, so anybody here that goes to a meetup and you run into like Rust developers, they're going to crap on Python because it's slow. It's slow. I'm going to admit it to you. If you need your script to count to 1 billion, Rust is going to do it a hell of a lot faster. That's one of the things you have to think about with the programming languages when we talk about fast, when we talk about slow, we talk about these things, is again, what the hell problem are you trying to solve for? If you're trying to do incredibly complex math, C++ or something like Rust is going to be better for you. With some AI things, again, C++ is probably going to be better for you. For most of the stuff that everybody is going to be doing in this room, again, calling Python slow is a bit, it's kind of like calling a Maserati slow. It's like, well, that Maserati is so slow compared to a Concorde. And you're like, well, yes, that in fact is true, but I'm not sure what the point is. So anyways, that's going to be one of the things you hear, is that Python is slow. And it's like, well, yes, I guess. Anyways, there we go. There's a bit of an introduction. Any questions? No? Cool. So we go to, I'm going to try to, oops. I figure out how to use my own computer. Up. Okay, so I'm going to try to show you guys where we are here as we are here. So page 2, I guess. So again, what is Python? So Python is what is called an interpreted programming language. So this is very important. So what an interpreted programming language is basically, you are going to write your program in plain text. You can call this ASCII or you can call this UTF-8 if you want, but basically you're going to create a text file. That text file is going to be read by what is called an interpreter, and that interpreter is then going to turn that into the program that you're going to be interacting with. So the important thing to understand with this, with interpreted programming languages, is that you have to have the interpreter installed on your computer. If Python 3 is not installed on your computer, Python 3 scripts will not work. It's kind of like if you have a Word document and you don't have Word installed on your computer, you can't open it up. Same basic deal. So that's what we're talking about. One of the big issues when you start dealing with interpreted languages, though, is it is software, and so it does have versions just like any other piece of software out there. So especially we're going to be using something called, again, Python 3. Python 3 generally, when it's installed on a system, will be at least Python 3.9, but you'll see versions all the way up to 3.14 at this point in time, and these are just different versions of Python. For today's class, it will not matter. But when you go out into the real world, it may matter. When you start using specific what are called modules, we'll talk about that later, some modules require specific versions of Python. You have to have at least Python 3.12 for this to work, or you have to be before 3.12 for this to work. So that's just one of those things to keep in mind. Do remember with Python, a lot of the modules, a lot of the add-ons that we're going to be using are open source. And open source is great for many things. One of the problems you run into, though, is it doesn't necessarily get updated very often. And so that's where you might be creating a project where you need to use this module or this add-on component. And the fact of the matter is people stopped developing it about 5 years ago. So again, it was certified for Python 3.11. But when you try to run it with 3.14, they tweaked something, and so all of a sudden that code doesn't work anymore. So this is one of those weird things just to keep in mind. You will hear about Python 2. You should not have to worry about Python 2. Unless you're a real technology professional in a real enterprise environment, hopefully you will never have to deal with Python 2. So basically, with most of these interpreted programming languages, like if you deal with PHP. So when I started dealing with PHP, it was PHP version 4. Now they're all the way up to PHP version 8. The thing is, if you started learning on 4 or you started learning on 8, more or less, the code is the same. Some functions have been deprecated, some functions have been added, but more or less, if you write PHP, PHP has been PHP for 20 years. Important thing to understand with Python 2. Python 2, for all intents and purposes, is a different programming language. Basically, the people that were developing Python, they got up to Python 2 and they said, wow, we have like some really great ideas. And now we see that we also have some really bad ideas. So we are going to take those ideas with the new ideas, a better way of building this stuff, and go on with Python 3. So again, we are now in 2026. Python 2, I think was supposed to die. It was supposed to die in 2012. It officially died in like 2020. But again, legacy, you will probably still see it in the world, but do not develop for it. The big issue for this is going to come up. If you go to Amazon, like I like Dummies books, I can't lie, they're just a really easy way to learn things. If you see a Python for Dummies book for 99 cents, probably don't buy it because it's going to be for Python 2. And again, and this is one of those things like, well, no, I can learn a little bit from Python. No, don't learn Python 2. It's an entirely different critter. Don't worry about it. So that's going to come up. Let's see here. When we talk about Python, one of the big things that we're going to be using is something called modules. So this is a bit different from a lot of programming languages. So a lot of programming languages, again, PHP, again, I like PHP. I know it's 2026, but it's still one of my favorites. One of the great things with PHP is almost all the functions are built into it. If you need a random number, it already has a random number function. If you need to email, you can literally email directly from the PHP language without adding anything additional in, and that's how most programming languages are. The curious thing with Python is, you need to do almost anything, you're going to need to import a module. So the idea with Python is it's a very component type programming language with the idea that you can swap things in. So what if somebody comes up with a random number generator that is a fraction of a second faster than the core random generator? It's like, oh, you can use that one instead. So that's one of the things that you're going to find is if you need a random number, you're going to need to import a module. If you need your script to pause for half a second, you're going to need to import a module. If you need the date and time, you're going to need to import a module. Almost nothing is part of that core. You're going to have to bring in it as a module. Those modules actually do come as the core package. So again, in the script itself, you have to import it. We'll show that to you later. Other modules you'll have to install. And again, I'll show that to you later too. So those are modules. The next thing that we come to is frameworks. So one of the big reasons why people want to learn Python is they're like, yes, I can learn this programming language and I can build web applications and I can build computer vision things and robots and all kinds of amazing stuff, which is true. The one warning that I will give you is many times the frameworks are much more difficult to learn than Python itself. So again, with most programming languages, the difficult part is learning the language, and then figuring out the add-ons is pretty easy. I'll just take a day to learn that. Again, there's one framework called Django, which we are going to have a class on in the future. It allows you to create very robust web applications. It took me a month to learn. Like, I literally sat down and was like, oh, I'm just going to take a couple of days to learn this, and then I'll create some classes. Yeah, about a month later, I stopped ripping the hair out of my head. So like, it was just like, what the, like, I mean, you know, the functions and the classes and the variables were the same, but how Django works, it took a lot to get your brain around. So that is one thing, like if you're thinking about using some of these frameworks, just give yourself enough time to realize they might be much more complicated than you realize. Okay, any questions up on that point? No, cool. Okay, let's see if I can do this to work. So we'll go to page 3. So I'm going to go through this, and then we're going to have our first little break so you guys can install all of this. So this up here is what is called VS Code. This is called an IDE, an Integrated Developer Environment. Basically what this allows us to do is it allows us to write code, and it gives us a lot of tools and functionalities to make life a lot easier. Again, when I started learning coding back in about 2000, I literally learned code on Notepad. which is complete and utter misery. The only way you know there is an error is when an error is out. The cool part about when you use an IDE is you'll notice like these color things. So like the variable is blue here equals the value is red, print is in yellow. It makes things very easy to see. It also makes things easy to follow. Like if I kind of highlight message, so that's a variable name, it will auto-highlight whenever that variable name is used throughout the script. So it becomes very easy to figure out what the hell is going on with your script. So basically that's one of the reasons why you use IDEs. We use VS Code. Again, Microsoft has created a lot of disasters in the past number of years. VS Code is not one of them. Almost truly, again, like one of the things too with Silicon Dojo is I want to actually teach you folks real technology. So many of the introduction to technology classes that I see in the world, they teach you technology by using toys. Like literally, there's just no functional use for any of the stuff that you're learning in the real world. One of the things that I'm trying to do here is I'm trying to bring in the real tools, even if it is a simple class. And so one of the good things with VS Code is almost everybody I know in the programming world actually uses VS Code. So if you learn VS Code, you get good at VS Code, you can put this on your resume, and this is probably what you're going to be using in your environment. Now, one of the things I will tell you, again, you're all adults out there, use whatever IDE you want. One of the big things in the technology world is standardization. So again, things like colors, things like error codes, all of that kind of thing. If you use the same IDE everybody else in your company is using, somebody else can walk up behind you, they're used to it, so they can automatically, you see what's going on. You use a different IDE that might be technically better, and it's going to look different, right? It's not going to be standard. So one of those things to consider there. So anyway, so we're going to be using VS Code. One of the things you're going to see over here is this is my workspace. So one of the curious things with Python is when you start running Python, you're going to get what's called your current working directory. And so this is going to be the directory that Python looks to for everything. If you ask it to read from a file, it is automatically going to look to that directory. If you tell it to write to a file, it is automatically going to write to that directory. So if you do not open up a workspace here, or if you're running Python code just from the command line, your default working directory is going to be your user root home directory. And so that, like if I'm looking at my computer here, that would be Eli. And that's probably why you see a lot of garbage here, because a lot of garbage gets dumped there when I'm doing my own random projects. So basically, the default, whenever you're going to be running Python code, is going to be the user's default home directory unless you modify it. Now, the cool part is, again, with VS Code, is we can open up this workspace, and now when we run code, so I can run this code actually in VS Code itself, when I run the code, it is going to use this folder as the current working directory. So this folder can be any folder that you want. So for me, again, when I'm doing these classes, I have this Durham classes, and then I just set this as my current working directory, and that has all of those files that you see there. So that's basically what's going on with that working directory deal. Let's see, beyond that, then you deal with extensions. And so basically what extensions are is they add on functionality to your IDE. So you'll notice things here like remote SSH. So there's something called SSH. If you don't understand what it is, that's fine. It allows you to remotely control like a Linux or another computer. So you can actually do that directly within VS Code itself by adding an extension. So if you're going to be doing like other programming languages, if you're going to be doing other functions with VS Code, you can add these additional extensions, and that will extend the capability of VS Code. One of the big things that you're going to want to do is you're going to want to install this Python extension, again, curiously enough from Microsoft. What this Python extension does is it gives you all this fancy color codes, right? So like if I try to do message and do see how it gives me like an error there? Right, that's going to come from the Python extension. So you have to install VS Code, and then you install the Python extension, and then you get this functionality. Let's see here. Beyond that, if you go to page 4, talk about installing Python. So if you're on a Linux machine, the only people here, I think, on Ubuntu, it's already set up. There's this whole thing on sudo apt install python 3 and sudo apt install python 3 -pip. So that's how you would install this on a Linux machine. If you're on a Mac machine, it's easy. It's gotta be a shocker. If you're on Mac, you just click, it installs, you do your job. Anyways, just making a point. So you go to python.org. So let me just do this. So if you're on Mac or Windows, you go to python.org. When you come here, you're going to see all of this. You're going to go to downloads, and then it'll most likely detect what operating system you're on. So it says download for Mac OS. And again, this is where you see the versions. So the current version is 3.14.2. So that's basically, you'll download that, you'll install that. If you're on Mac, that's all you should do. If you're on Windows, I remember this back in the day. Like, I had a Mac when I had my business. I had a couple of Mac specialists there, and one of the things that always came up is that I had spent so much time and energy learning how to administer Windows systems. I didn't want to lose that when I went to Mac. And basically, it's funny because my Mac administrators were like, "Yeah, you just don't have to do that on a Mac. Like all that stuff you spent like 3 years learning for Windows." Yeah, that just doesn't exist on a Mac. You just, like, you get the functionality, you just don't have to mess with registries or whatever. So that is if you go and you take a look at the Windows install on page 4. I don't know, they just make you do stuff for the fun of it. I don't really get it. So basically, you can take a look at this. So you're going to go to install it. When you do install it, you want to check off the boxes. Use administrative privileges when installing Python, py.exe. If you don't use the administrative privileges, you can get some wonky crap happening when you actually try to run Python scripts. And add python.exe to path. So basically, if you don't add the python.exe to what's called the environment variable for path, Python doesn't work properly. Why that is not a default, I cannot grasp, because you are literally installing Python. So why? Anyways, past that, you're then going to click on Custom Install. It's going to give you some options here. Might as well do the documentation, doesn't really matter. The big one is pip. So pip is basically how you can install additional modules. So when you go to install the Ollama module, or what's called the request module later in the class, you're going to need pip in order to do that. So basically click off the pip to make sure you do that, and then add all the other stuff just to make sure we don't run into any problems. Finally, at the end of it, you want to do the install Python whatever for all users, associate files with Python, create shortcuts, basically do all those checkboxes so everything works properly. So notice this, when you install on Mac, you go install and it works. When you install on Windows, you do all these additional steps to get you to the exact same place. Anyways, that's just how it is. One of the final things I will say, let me show you folks this before we get into our first lab, PEP 8. Okay, so Python is interesting. So basically, one of the big things Python was designed for is that it was going to be a language that was easy to read for other coders. One of the big problems we get to in the technology world is when you start developing your projects, it doesn't really matter if your project works, and it doesn't really matter if you understand the project. The question is, what happens if you fall over from a heart attack and somebody else has to deal with your code base, and they only have a week to get up and running? Can they actually read what the hell is going on? If you deal, again, I love PHP, but here's the deal with PHP. You can literally have just one line of code that goes from here all the way around the world 5 or 6 times, right? Or you can have a block, because in PHP, what's called the delimiter is going to be something called a semicolon. So as long as you put the semicolons in the right place, the code will run functionally. PHP does not care if you can read it, right? So one of the interesting things with Python is it was designed so that you can actually read what's going on relatively easily. So if I go here, let's see, this auto blog code, right? So this is code we'll deal with later. One of the things you'll notice is with this code, especially if you've used other languages, you may not necessarily understand exactly what's going on, but this is going to be relatively easy for you to read, right? And so the big thing with this is it has to be formatted in this fashion simply for the code to run. So basically, this is what we call with syntax. When we talk about delimiters, when we talk about spaces, when we talk about indentations, this is how it has to be formatted for the code to run. If it is not formatted in that way, the code is simply going to fail out. The issue that you get to is then called syntax. And what is styling. And what styling is within the technical rules for coding, you can do things in different ways. And so this is where we can see here, these are called the PEP 8 standards. So all of these code blocks function. They function perfectly within Python, but basically one of the things they're trying to show you is that this is the correct way to style your code, and this is the incorrect way to style your code, because to them this is harder to read, right? This is something called the PEP 8 standards. There is a link in your paper, so you can take a look at this. So basically, like it's showing here, so this all works. But for this, for adding things up, like here's a variable and then plus, variable then plus, whatever then minus, variable then minus. What they're saying is this is the wrong styling way to do things. The proper way to do it is to put the pluses and minuses before everything. And so this is what we talk about with styling versus syntax. So if you're just going to go home and build your own robots, do whatever the hell you want to do. If you are trying to get a job somewhere, understanding how styling works is going to be very important to you, right? The people that are going to hire you are going to go look at your GitHub, and even if you've got code that works really well, if it gives them eye strain trying to read it, they're still probably not going to hire you. So if you don't have any other alternative, do try to look at the PEP 8 standards and code things based off of PEP 8. The other thing, though, is do remember in the real world, every technology professional believes that their wheel is the best wheel that's ever been created. So if you go to a company and they have their own styling standards, do not be the aspie to stand on that hill and say, I will not do anything other than PEP 8. Just do whatever the hell they're doing. So anyways, that's the difference between styling and syntax. So with that, we are going to get to our first lab of the day, so we can actually start doing the rest of this. So basically, for installing VS Code, so if you're on Mac or if you're on Windows, if you go to page 3, you're going to have this https code.visualstudio.com. Code.visualstudio.com. You come here, and one way or the other, it should give you a download link. So download for Windows, download for Mac. So you should download this, and then you should install it. You install it. Once it's installed, you will run it the first time. When you run it the first time, what you're going to see is these little square block things right here. That's for extensions. This should show up automatically for you. What you're going to see on the side is you're going to have these recommended extensions. One of those recommended extensions should be Python. So then you're going to click on Python, and then you're going to install the Python extension. And so this is going to give you all the color codes and that kind of stuff. Past that, then when you go to page 4, you need to install Python itself. Again, you're just going to go to python.org, like I showed you. If you're on a Mac, it's going to be a very seamless process. You're going to be like, wow, that's why I spent $3,000 on my computer. If you're running Windows, I've got instructions for you. Just follow those instructions. Basically, just install everything. And we will pause now for you folks to do that. Give everybody about, I don't know, give us 10 minutes. Let's say 10 minutes or less. Again, I'll just say how long I think it should take, and then we'll see how that goes. If you need help, if you have a question, ask a question. What's that? Oh, later? Or, yeah. Oh, no, let's break breaks, actual breaks. I'll chat. Yeah. If you want to chat, like I said, I'm more than happy. Like this is going to be a bit of a mess, so we can chat. Yeah, bigger break. Yeah. What's that?
How do you feel about the Python install manager that they're pushing these days?
Oh, crap. What's that one?
That's what they're trying to push. Python's not trying to push everything to the install manager. You have an install manager that then manages your Python packages.
Oh, I haven't played with that one yet.
So to install that by default, but then your instructions were say Python, so I installed what it did the way you said. But
Yeah.
I don't know if you had experience with that or not.
Oh.
Python install manager is what they're pushing everybody to on Windows.
Christ. I guess that'll be for the next class. I have no idea on that, honestly. I don't know on that one.
This one?
You can go to Windows.
I did a Pippin upgrade.
Oh, yeah?
The remainder of those I installed like through a GUI, so they came to my documents.
Okay.
Is it an issue if I just updated and it went to my user, the local user bin, like you said it does? Is that an issue?
No, I mean, if it's installed, it should just be fine. Yeah, it should be fine. Hopefully it'll be fine. I don't know.
Oh, you can go back.
Okay.
Yep.
Do you need any of the stuff, like the debugger and the rest of the stuff?
No, just the Python should be fine. Yeah. I think it should be fine. We'll see.
That says something like not configured to allow pass longer than, okay, that's nothing, right?
Yeah, they're using it, yes.
Okay, so we've gone.
This is so that you can use Python with stuff like that.
Okay.
But yeah, you can just hit Y for yes. You know, basically, remember you were talking about the directory?
Yeah.
That's where this is where this is starting to go.
Okay. Wait a minute, we can add, so this would be my local directory, but you will need to restart your terminal to use it. But I won't be using it, because I'm gonna be using what's in.
The compiler.
Okay. So I'm okay with putting it in that directory.
That's right.
You might have the latest version because
Oh, I just checked it, so it's got checked on next to it now.
Yep. And I'll get there. Feel like a mouse in a maze here. Yep.
Do I need to create the folder first? Or
Oh, so you can do that to like your desktop, your documents folder, or you can create a folder and do that. Yep.
Okay. I was like, is it supposed to be there?
Yeah. No, you can do whatever you want. Yep.
Did I set everything right? I couldn't find this one. I couldn't find this one, but I think I downloaded everything. I created a folder.
How do you? So extensions installed. Okay, there you go. Okay, you got your workspace somewhere. Yep.
Yeah.
So that should be good.
I created this one.
Yep. Yep. That looks
So
good.
that's good?
Yep.
But how about this one? It says
Oh, so for
change the setting.
so if you want to change.
I guess this is window.
It is window.
I did find. I
Oh,
guess
yeah,
I
if you
went
find-
to search to find the setting.
Okay. Yeah. So if you
What
want.
does it say?
So, okay, so you got so X that. So like word wrap, so you can type in like word, so any kind of thing like that, word wrap. So word wrap is if the sentence goes, if sentence goes on, then it'll wrap back. So you might
Okay.
want to turn word wrap on. So the settings is where you can add all that kind of.
I see. So I can say just
Yep.
Okay.
Yep.
like that.
And how about, I guess, you're going to Python? I already installed Python 3, but this one doesn't work. Maybe it's bad.
No, so that's it. We go to view.
So it is the, what is this?
Where
the
is-
DS something?
Oh lordy. Yeah. How do I get to terminal? Oh, so yeah. Oh, I know the problem.
Oh, no, I have to create one.
Okay, so I'll have to tell everybody.
That's
so
just a command.
yeah, so Python version, so that shows you what version's installed. So you have 3.13
Yeah.
installed.
So I'm fine, right?
Yep.
That means I'm fine.
Yep, yep, you should be fine. Yep. And so yeah, like so you should do pip.
What about this pip stuff? Did we say something about pip?
Yeah, I think you installed it. I think it automatically installed. I think I can do that.
Yep, so you have pip installed too. So you're good.
Okay.
Yep.
What's this one? How did you
So that's a terminal. So that's the same thing as like the command
How
prompt.
did I open that?
So if you go here, you can click on.
That's under Vision, whatever.
If needed, we can always
That's under which one? That's a VS Code.
That's VS Code. Yeah, yeah.
I see.
Yep.
Okay, got it.
Okay.
Okay. Thank you.
Yep, yep.
Okay.
So when I installed this morning with Parkland, I didn't get like the little pip.
Yeah, these things didn't come up for us.
Did you do the optional?
Well, I just installed it directly from Python, from the Python site.
So you downloaded it, installed it?
Mm-hmm.
Just go to command prompt
Okay.
or go to terminal. And that so you do pip space hyphen version.
No.
Yeah.
So I just need to. Can I install it from the studio?
No. You got to go through.
Python.
So I gotta go back to.
Yeah. So download the Python. So download install. Oh, they changed this shit. Go to download. Yeah. Oops. Change.
We're in the same place.
Yeah, they changed things. So yeah, do download there.
Wait, where are you? How did you get this?
Downloads. And
Windows.
Windows.
Okay. And then which we did?
The first one.
The same one that we did before? Okay.
And then here, can I see your computer for a second? That's all. Yeah, they changed it. Let's go up here. So let's do downloads or get the standalone installer. Okay.
Oh, he went to the standalone installer.
Where is that?
Yeah.
So go scroll down,
Okay.
or go back up, and then go back to downloads, and then go to.
Yeah, see that standalone installer?
3.4.2.
Okay.
Yeah. See how now you've got this whole customized thing. So just run through that.
Okay.
Oops. Here. Okay. So heads up. Okay. Oh, Windows. Notice I'm not talking to anybody about Mac systems. Anyways, so I don't have a Windows system here, so it's hard to show you. So when you go to Windows for the Python install, right? So you see how I have download for Mac? Yay! Windows, you've always got options. Anyways, so there's going to be this weird installer thing here. Don't pick that. There's going to be the download, the whatever, install. So download the second one, and when you run that, that's going to get the standalone installer, and that's going to give you all these options. So if you run the first one for whatever reason, people aren't getting pip. So just do the second one. The other thing too is if you're on Windows, you don't have to type Python 3, you just type Python. So that's one of the differences. So the big thing is to make sure you're doing it right, if you go to terminal, new tab, basically what you should be able to do is either Python 3 or Python. You should be able to do, and it'll give you a version. So I'm on 3.14.2, and then I should be able to do pip version, and it'll give you something. So the Python is the most important thing. That's the most important thing. And then pip, well, actually that's gonna be important. They're both important. Make sure you get something for both of them. Wow, that was 10 minutes already. How many people are not finished yet?
Where do you want us to just be up to installed?
What's that?
You just want us to be to the point where it's installed?
All I need is for you to be to this point.
Yeah.
Yep. As long as you have pip and Python, we're good.
debugging?
I don't think you need
No, no debugging. All right. Install, right? Uh-oh. Yeah,
What's that?
another Windows thing.
Another Windows thing.
Oh, Jason, we both had the same.
Setup failed?
Yeah.
Please fix the issues.
No? Okay, hold on. You're going back to,
I think you have to uninstall it and then reinstall it.
oh. What
Okay.
did we do? The manager?
No, the same one.
This one?
Mm-hmm.
Uninstall, and then we'll do it and then add these
Redo it
things.
again.
Okay.
Yeah.
We might have.
No, no worries, no worries.
Because we put in those parameters on the first one, and now we're trying to reinstall it. Okay.
Okay, so we got 2 here that are still working. Is anybody else still working? You're still working? Do you know what you're doing, or are you on the path? Just staying a long time? Okay, that's fine. Okay, does anybody have issues? You should be fine. I think yours is fine, hopefully. Yep.
That's just one.
Yeah, this doesn't connect to the internet.
Oh, second floor.
Yeah.
Oh, forget connection. That's why we got multiple ones. A second floor, right? Because all of these connected last night. Okay. Cool. Here on out. Yep. Okay, so we have 3 people still going through the process. You're on. Ugh, hard to hear you. What's up? Oh, yeah, yeah. So you go to the command prompt, and that's where if you go to the command prompt, so you're on Windows. So instead of 3, do Python space, dash dash version, and then pip space dash dash version. Oh, no. So just do that, and then hit enter.
You're already in Python.
Still NC under the hood.
Oh, you're in Python? Oh.
So yeah, your version is right there at the top, right underneath the line where you put Python.
Yeah, so type in exit, EXIT,
Still got like XP going.
and then there you go. So, yeah, so.
Okay. I was like, hey, let's try that.
Oh, yeah.
And then it'll tell you what program that you're using, or the information will just come.
Okay. All right, back to class. Back to class. You got your 15 minutes. Back on your heads, as they say. Okay, now one of the big things is whenever you're dealing with the technology world, you're going to hear about shells. Like almost every program, especially on Linux or Mac, you're going to use has its own shell. So you'll hear about like the MySQL shell, the Postgres shell, the Linux shell. Python also has a shell too. So do be very careful with this. So notice what my prompt looks like here. Now, this can happen to anybody, right? So you type in Python 3 because you're going to run a script, and you're like, oh, what's the script I'm going to run? And then you remember the script that you're going to run, and then you hit enter, right? This is going to drop you into the Python shell. You see how you see this arrow, arrow, arrow here? It does not look the same. Well, if I try to do LSL, That is not a Python command. That's like a Linux, a Unix shell command. So you're gonna start getting all kinds of weird problems, right? So I can do like here I can say like message equals hello class. And then I can say print message. Yay! So basically you're able to actually interact with Python in a shell environment. This is one of the reasons why Django is a complete disaster to learn. Their initial configurations, when you start using their tutorials, actually put you into the Python shell. And so the problem is instead of just writing one Python script, and then if there's a problem, you can fix it, you go into the shell, and when you're not really sure what command you're supposed to put in, you fat finger the command, and then all of a sudden you got this whole mess going on. Anyways, that's Django. We'll do a class on that later. The important thing, basically, unless you know what the hell you're doing and why you're here, which you probably should almost never be here, what you're going to want to do is you're going to type exit function, and that is going to get you out. Basically, the only thing you have to worry about the Python shell is how the hell to get out. It's exit, 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 exit. Yeah. So like that's one of the big things, especially when, again, you get into this technology world, is you get into these shells. Literally understanding how to get out of this shell can be one of the biggest pains in the butt. Because sometimes it's got to be exit with parentheses, sometimes it's got to be dot exit, sometimes it's got to be slash exit, sometimes it's got to be some other keywords. So just something to keep in mind. Okay, are you guys about there? Yeah. Yeah, probably. Okay. Oh, let us get to page number 6 then. And again, with all of this stuff, since we do have a large class, the concept is basically what I'm trying to do here is I'm trying to give you all enough time for 90% of you to hit the finish line, frankly. Like if you all don't get there, I'm not worried about it, so you don't be worried about it either. Again, you can take all of this material home. You have your books and everything. So if you can't finish anything in class, don't stress out about it too much. So I've just got a lot of people to keep going in one direction. Okay, so let's talk about modules. Module use. So again, I can go here to my workspace, and I can come here to the script I want to take a look at, and this shows me modules. So again, one of the things you'll notice in this particular Python script is incredibly simple things require that you import modules. Now, a lot of these modules that we're going to use are what are called core modules. They're going to be installed when you install Python, so you're not going to have to worry about it. But there will be some additional modules as we go that will have to be installed. So for this particular script, all we're going to be doing is I'm going to be printing out, I'm going to create a random number, a rand int between 1 to 200. I'm going to print out that number. I'm going to sleep for 3 seconds, and then I'm just going to print out, this is how you access functions. Anyways, basically a pretty simple thing just to give you an idea of what's going on. So if I hit run, so basically, since I have the Python extension installed, if you don't have this little run button up here, it most likely means the Python extension isn't installed. So since it is, I can simply click on that, and then it'll run down here in my little terminal interface. So it says I get the 38 as the random number, it waited 3 seconds, and then it printed out this string value, right? So we take a look at this. You have a couple of ways that you can interact with the modules and the functions. So basically, if you want to be able to call the function name itself, so random is the module name. So we can say from the random module, import, and then I can say the very specific functions. So when we start getting to more advanced projects, this is going to be a longer and longer line of what we're bringing in. But for this, all we're going to be doing is bringing in rand int. So the nice part about doing it this way is basically I can now just simply call the rand int function as just rand int. So since I imported rand int, I have rand int in my little code space, so I can call that specifically. Now the other thing that you can do is you can import an entire module. So the idea is you import all the functions in that module, so every function in that module should now be available to you. But since you're importing the entire module, you have to tell the code basically what function you're going to be using. So for sleep, I'll use the time module, the sleep function in the time module, and then I'll do the 3 seconds. So basically, if I import the entire module, I have to call the module and then the function name. If I call just the function itself, I can just call the function name. Pretty simple there. One of the things you do with this, one of the reasons you do this type of thing is what is called namespace. So Python can be an absolute disaster for namespace. And what namespace is you can't call two different things the same name, or you'll run into conflicts that will become very bizarre. And so one of the ideas here is by basically importing the modules this way, you can keep from running into problems with namespace. So especially if you just import the module itself, so time.sleep, you're never going to use time.sleep anywhere else for something different. So basically, so if I do rand_int, theoretically I might create my own rand_int function. I might be like, oh, I want to create my own rand_int function after I already imported rand_int, and then it can become a bit of a disaster. So anyways, this is kind of one of those things. It'll make more sense as you start coding more in Python. So that's the basic idea with modules. You will see down at the bottom, I didn't really give you a demo of this. You can do what are called aliases. So if you do like import time as clock, now that module, you're going to interact with it using the alias that you gave it, clock. So like this is one. So one of the modules we use a lot in class is called Open Computer Vision, OpenCV. And like again, if you look at their code, I don't really understand what's going on. So basically, it's like import CV2 as CV. I guess they just don't want to put the 2 at the end. 2 is just too far for them. So anyways, that is one of the things you're going to notice, like especially if you're copy and pasting code. A lot of times you'll see that they put aliases, and you just got to keep track of those aliases. Any questions on modules or aliases? Yep.
Is there a way to list out what functions are in a module?
I'd probably say Google search. There probably is a way to do it, but again, that's why we have students to ask those questions. I'm not sure. Yeah. ChatGPT will answer the question. Yeah. Yep. Actually, I think like so if you go PyPy. I don't know. Do they have time here? So PyPy, this is the repository for all the modules. So what's great about Python is just like Linux, where you can just do pip install. It goes to the repository and just downloads and installs the module. So pypy.org is where those modules are at. Yeah, so they don't have just time here. So if you're looking at other modules, so let's say bottle. So this is a framework we use. Well, anyways, there might be the information here. You might have to go search for it. But,
What was the name of this?
this pypy.org, but we'll deal with that in a second. Okay. Question. Yep.
So could you put for random, don't put the import, still
Okay, I feel like I'm not gonna need to do
Right. What's that again?
If you put, so at the beginning you put from random.
Yep.
Import random.
Yep.
If you didn't put the import random, can you still call the random? So like number equal random, it'll still be called if you just put from random.
So you're saying here, so
You have to put import random.
yeah, because this is importing the function. So you have to import every function that you're going to be calling. Yeah, so there's like random word and random, there's a whole bunch of, different stuff.
So on that note, you can import random, and that would include everything, including random?
Yeah, so if you did, so if I did import random, oops,
Yes.
then basically what I would have to do here is I'd have to do random.random. So, yep. All right. Everybody kind of understand what's going on there? Yep, cool. Let me close that so I do not save that. All right. Lots of talking. Is everybody kind of, sort of, where are we at? Okay.
So
Yeah.
the time dot sleep.
Yep.
Dot sleep, that function, or that's the function, right? The sleep to the function.
So time is the module, sleep is the function, yeah.
What does the sleep function do?
So it pauses for 3 seconds. So yeah, so you see when you run this code, you automatically get 86. 1, 2, 3. There you go. Then it prints out. Yep. So if you need to pause the code for some reason.
Where do I see what modules I have
So if you
installed?
type that,
So we'll get to that in a second. Yeah.
and I'll show you where it compiles it. So basically, what's happening is
Okay.
So do the whole thing?
To the class. Now to pip. Now to pip. Everybody. Okay, so pip, again, is going to be what's called the Python installer package. So I do believe in Python there's different ways that you can install packages. We're just going to use pip because it's a nice standardized way that 99% of people use. There's other things that you can use. Have fun if you want to use them. So we're going to be using pip. So basically with pip, again, in order to understand what modules are already installed, I can go to my terminal window and I can do pip list. And this is going to install, or it's going to show me all the modules that I currently have installed. So world famous Pi Audio, which is a complete disaster to use. We got Ollama here, we have Open AI, we have Open CV. So this shows me all of the different modules that I have here, right? Basically, when you're going to be installing modules, so there's a number of ways to install modules. Basically, what I tell people to use is Python 3, or Python if you're on Windows, --m, pip install, and then module name, whatever the module is going to be. So you can just use pip install. The problem that you run into is you can have multiple versions of Python on your system at the same time, and especially when I'm dealing with a class. So if you're just dealing with your computer and your environment and you just want to use pip install because you know what the hell is going on and you're responsible for troubleshooting it, God bless, do whatever you want. It's a lot easier. The reason that I use Python 3 --m pip, so what this is calling, this is calling the interpreter that is currently running. It is saying basically in manual mode, run pip. So in this interpreter, run pip, and then install the package, the module that I want installed. So this, again, when I'm dealing with a classroom, is 99.99% most likely to put the damn module in the right place. If you use pip install, the package might get installed somewhere else, and you've got a nice little troubleshooting routine you got to go through. So that's why we use this here in class. So if you're like, all of my buddies just use pip install, that's why. And to be clear, 99% of the time, it'll work fine. It's just when I've got 30 people in a class, there's a chance one person's computer is going to be configured in a different way, and it'll go somewhere else. So basically, that's what we're doing. So that's how you install the module. So that's how you list the modules. That's how you install the modules. And then if you want to uninstall, it's just simply, again, Python 3 --m pip uninstall, and whatever the module name is, you uninstall it. So sometimes for troubleshooting purposes, you'll have to uninstall, or you might have to install like an earlier version. So again, there might be 5 different versions of a module out there. You install the latest, you find out the latest doesn't do what you need it to do, you uninstall that, and you install an earlier version. Just one of those things to keep in mind. Let's see here. Again, if we take a look at this, you can do pip install module. You might also, especially if you're on Linux, you might use pip 3 install module. Because again, the original pip was for version 2 of Python. So especially on Linux, there's actually pip and pip 3. Again, so it's one of those things you got to kind of figure out, have fun. This is why we get paid as technology professionals. Again, the important thing to understand if you're not actually a technology professional right now is 90% of our salary comes from the stupid crap developers did, and we're responsible for figuring that out. Like literally, if this stuff made half an ounce of sense, they would fire 50% of us tomorrow. But it doesn't, so we keep getting paid. Anyways.
Mechanics of the computer world.
Yeah. So that is pip. Let's go to page 8 and VENV. Okay, VENV are virtual environments. So basically what virtual environments allow you to do is it allows you to basically create kind of like a little bubble for your Python code to be able to run in. The actual important reason for this, especially if you're running your Python code on a server, one of the issues that you might run into is one script requires one version of a module and a different script requires a different version of a module. The thing is, if you install the module just into one library, it's going to be that particular version. So you can create these virtual environments, so basically you can kind of put them in their own little bubble. Also, technically from a security standpoint, it's better, but nah, that's a little iffy. This will come up a lot if you're using Raspberry Pis. So if you use the Raspberry Pi OS now, you actually have to use virtual environments. In Silicon Dojo, we generally stay away from virtual environments just because it's just a simple extra level of complication. It's hard enough to teach you folks how to install pip, so I try to keep this as simple as possible. So anyways, but virtual environments exist. If you want to create a virtual environment, basically do Python 3 space hyphen m venv. So again, this is Python 3, and then I'm manually running this module called venv. Past that, you get to name your virtual environment whatever you want to name it. So you can get as creative as possible. But again, we're in the technology world, so we try not to be creative. So the best thing to do is literally just try to call it venv. So what this does is it calls the venv module to create a folder called venv. And that way, if you do it this way every time, no matter what script you go into, you always know what the hell the name of that folder is. Right? So basically what's going to happen is I hit enter. It's going to take a second. I should get my little venv folder somewhere. Where's my venv folder? Top. Oh, there we go. It gives me my venv folder. So what I can do is I can do source venv. So this is not the command. This is literally the folder name. /bin/activate. And when I hit enter, you'll now see my prompt says venv. So basically what that now means is I'm in that virtual environment. So when I run the code, any modules that are there will run. And what you'll notice is if I do pip list at this point, I get pip. That's literally the only module that's currently installed. So when I did this before, I got like 50 modules. So when I do it this way, I've only got that one module. So anyways, there's a lot more that goes along with this. There's something called a requirements file that you can create. You can actually export a file of all the modules that are installed in your venv. So if you need to reset it up again, you can simply import that one file and it will auto-install modules for you. But that gets into a bit more complicated, and we've already got a lot of stuff to go over today, so we're not going to go there.
But it's not just for information. You don't want us to try that today.
Yeah. Don't worry about this today. You do need to know that this exists. So when you see venv come up, you're like, oh, Eli said something about that. Yeah. Okay. Any questions about virtual environments? Yep.
So outside of like what we're doing today, what would be the purpose of that virtual environment?
So when you actually go to deploy things, so when we ever get to a class, like if you're going to be deploying a web application to like DigitalOcean or something, they almost always require that, again, you're in a virtual environment because they want to try to compartmentalize what you're doing. Are you here for a Python class? He seems to be a bit lost. Hey, are you here from Python? Yeah. What's that? Yeah. Okay, grab a seat. You are well late, so we'll try to keep you up, catch you up at some point. Oh. Here's the book. Get to keep the paper, you don't get to keep the book. Okay. So now let's get to the basic Hello World script. Okay, so let's go to page 9. Page 9. Okay, so this is basically the script everybody uses. Hello World, I don't know, back with C or whatever, 80 years ago, they typed Hello World, so everybody now types Hello World. So if you ever see Hello World and you're like, what the hell is this about? It's because somebody basically used that as the default message 50 years ago, and so now we all use the exact same thing, because that is how innovative we are as technology professionals. Anyways, so the main real use for this, so I want everybody to type this in, and hopefully this will work. So you can either do file, new file, or you can do control N, or command N, I guess. So either control N or command N, and you can type this out. But basically what you're going to do is you're going to type out message equals, and then this is going to be what's called a string variable value. With string variable values, you can either put them inside single quotation marks or double quotation marks. More or less, for 99% of the time, the double or single quotation marks don't matter in the Python world. The big reason that the double or single quotation marks will matter is when we start outputting to things like HTML files. So in HTML files or CSS, they also need to use quotation marks. So basically, you don't want to use the same quotation marks you're outputting to. So that's why you'll see a difference between single and double quotation marks. So anyways, message equals single or double quotation marks, whatever your message is, hello world. And then you use what's called the print function. You call the message variable, and then it should print out that value. If you click on the little run button up here, it should then get you hello world. Woo! Exciting stuff. The other thing too is if we go to the command prompt, let's see here, terminal folder. So you have to be in the right folder. So if you go to command prompt and you want to be able to run this script, you do Python 3, or if you're in Windows, you do Python. You do hello.py, and that will run the script for you. So that shows us that hello world is working.
Did I say what? This thing here?
Here's some talking. Is everybody following along? All right. So basically, you can create the file, again, by doing File, New File, and then you can save it. You can do like Save As, and then test.py. So again, this is going to be a big thing. So since this is an interpreted programming language, extensions matter. So .py is the extension for Python. So whenever you create one of your scripts, you want it to be called .py. Have many people gotten hello worlds yet? You don't have nothing. What? Well, come on now. All right.
Something's missing.
Yeah, what are you doing? Message equals hello world. Well, okay, did you install? Okay, it's Python extensions installed.
What is cat on here?
Oh, wait a minute. File, save as. Hello.py. Message equals hello world. Oh, yeah. Is it working for you?
Yeah, that worked for me.
Here, let me just
I
close.
think you need to activate the installer. Or the debugger.
Okay, there we go. Hello world. Okay, so now, yeah, since it's initially installed, anyways.
Okay.
So if anybody is having so you just installed VS Code, you just installed the Python extension. If you're having issues, restart your VS Code. You should down here, it's going to be impossible for you to see in back, but down here, you're going to see this number. So you see Python, and it says 3.14.2. That's showing what interpreter is running in VS Code. So you should see a number down there. If you don't see that number, restart your computer, or restart VS Code, just VS Code.
I have to save the code before I can run it.
Not necessarily. Well, if you make any changes,
You have to save it the first time.
save it first.
The first time. You can like now you can say hello Bob. You don't have to save it and it'll run, but it has to be saved the first time for it to run. Yeah.
Can you show where you did it in the terminal? Where you ran the code from the terminal?
Oh yeah, you just have to be in the right folder. That's the whole problem with you guys. So this is my intro to Python full day class folder, right? And so if you do see Python 3 space and then whatever the script name is, that's yeah. You just have to get to that folder, wherever that folder is. You gotta get to that. Okay. Has everybody gone hello world? Yes. Okay, there we go. I need a response back from people. I got 30 people in this class, or 24 people in this class. Need responses back. Okay. The next thing to think about is comments. So we're not going to go into this a lot today. Basically, all a comment is, it is this hash sign, so the over the 3 sign. When you comment something out, basically this allows you to either write a note. So you'll hear about commenting your code, right? Where I can go, this is a comment. And see, when I run this, it doesn't affect the code, right? So that's a comment. Why that's important is because if I don't comment that out, it thinks that's something, and when I go to run it, I'm going to get this error. So basically, when you comment out, that's what you're doing. Another reason that you might want to do commenting is you might want to have multiple things, so like message equals this is a test. So especially when you're troubleshooting, right, you might want to put different configurations to see what works. So here what I can do is I can simply comment out the hello world, and now I get, this is a test. So it's like, oh, okay, I'm making sure caching mechanisms. The other thing that you can do, and this works for both Mac and Windows, is either so it's either Command on Mac or Control on Windows. You hit Command or Control plus the / under the question mark, and you can comment in or out multiple lines of code at once. So this is going to be a big deal for troubleshooting. If you have a whole block of code and you just want to get rid of it for some reason, you can comment out that whole block of code, run the script, verify what's going on, and then. Keystrokes again? So that is you're on Linux. So it should be Control and the question mark / Should be.
You get to highlight it first?
Oh yeah, you have to highlight it first, so that it knows what you're trying to comment out.
Oh, you can do it. You can uncomment it.
Yep. Yep.
That's pretty cool.
Okay, so those are comments. Any questions on hello world or comments? Nope. Okay. So now let's go to the variable.py. Okay, so variables, this is a fun thing, variables and data types in programming languages. So what a data type is in a programming language is you're assigning what type of data a variable value is. So you'll hear about an int. So an int is a whole number. Depending on your programming language, God knows what the size of that thing is. It's like -3 million to +3 million. In modern programming languages, they're absolutely massive. So basically, generally expect an int to be a whole number. You will have a float or possibly a decimal. This will be a number that literally has a decimal point in it, right? So 1.25. So an int has no decimal points at all. So basically, if you put 1.25 into your script and it takes it as an int, you'll keep the 1 and you'll lose the 25 cents. So imagine if you do that in an inventory control or an inventory control system or some kind of invoicing system, that can be a bit of a disaster. So anyways, an int is a whole number, a float is a decimal point number, and a string is literally just text. Depending on the programming language that you're dealing with, they have God knows how many different data types. You have to take a look at whatever programming language you're dealing with. In the Python world, it is generally going to be int, float, and string. If you're dealing with languages such as C++ or some of the more sophisticated languages, you'll see things like tiny int. The reason for that is whenever you declare a variable, it is going to take a certain amount of memory. So it's going to basically say within your RAM, we expect that this variable value will take so much memory. So when you put an int in, it will put a decently large chunk of memory and it will allocate that for the variable value. Again, this is where we talk about why C++ can count to 1 billion much faster than Python can. Because in C++, you can do something called a tiny int. And so it's going to be a number, but it's going to be a small number. So since it's going to be a small number, you only need a little bit of memory. So it's only got to allocate a little bit of memory. Okay. Again, we're not dealing with those languages. We're dealing with Python. Python is a much simpler language. So anyways, that's why you deal with int, float, and string. The other interesting thing is that in most programming languages, you're going to have to declare the data type. So basically, it's going to be like number as int, something like that. So I'm creating the variable, and I'm declaring it as this type of data type, this data type. Normally, you see that, or you see a typeless programming language, such as JavaScript. One of the reasons people hate JavaScript is it doesn't have data types. The problem you can run into there is what happens if you try to add 1 plus Bob. It becomes issues. I have 5 plus 6 plus 7 plus 105 plus Bob divided by 12. What does that come up to? That comes up to a mess. So one of the big things you want with programming languages is you want what are called hard fails. So what a hard fail is you run the code and it fails. It doesn't do a damn thing. You're like, crap, it doesn't work. Right? That is frustrating, but you know it doesn't work. You go back to fix the problem. The problem is, if you don't have a hard fail, and you have 1 plus 6 plus Bob divided by 12, and it doesn't just fail, what happens if it gives you an answer? Like, when was the last time when you added something up in a programming language, you actually went to a calculator to verify that the numbers were correct? Right? So one of the problems you can get to is with some programming languages, if they don't give you that hard fail, it's called a soft fail, where it is an incorrect answer, but it does work. And that's where you can have a real disaster. And so that's the thing, like with JavaScript, you can run into problems, is since it's a typeless programming language, it doesn't have data types built in. There's something called TypeScript that you add to JavaScript to make it a typed programming language. Anyways, the interesting thing with Python is like, oh, we just don't want to be like everybody else. That's so boring. We want data types, but we don't want you to manually assign the data type. So what it does is it will automatically assign the data type. So when I create int equals 1, not only do I create the variable int, not only do I set the value to it as 1, but it also then gets declared as an int. So you do have a data type, it's just automatically assigned. And so this can be a problem in your script when you don't realize how things automatically work. You can run into some weird breakages. Anyway, so with this, basically we're just doing this. Down here, we're going to use the print function as we did before. So you guys aren't going to do this. You don't have to mess with this. I just want to show you the demonstration. And then there's a function called type. So you're going to learn to love this particular function. It is a very simple function that's going to save your life. Because what you do is you can do print type and then int, print type float, and print type string. And what this is going to do is it's going to print out what the data type is so you know what the hell you're dealing with. Right? So basically I can run this. And as we can see, class int, class float, class string, so I know what I'm dealing with here. There is also a function, basically where you can use, so str is the function. It's either int, str, or float. And then you put the variable in there, and it will change the data type to that particular, you'll change the data type to that data type, right? So we have float equals string of float. So we want float to become a string, and now when we print this out, it is going to be a string, right? So now 1.25 is going to be a string. So the big thing that you're going to be dealing with here, just so you realize it, is we're going to be using something called the input function a little bit later. The input function allows you to type things at the command line for that to go into your code. It will automatically put anything that you put in there. It'll become a string. So if you're putting numbers in, so let's say you want a mathematical, then you've got to turn it into an int or a float for that to work. The other thing, again, is just to remember this whole int float deal and make sure you know why you're using an int or why you're using a float, because you can run into a problem. Again, if you strip off all the decimal points and you need the decimal points, that's an issue. Okay. Any questions about variables in general? Yep.
Are those the only 3 data types in Python?
No, so there are more, so we're going to talk about collections in a second. If you go through, I think there's about 15 different data types, but they get again, I'm trying to keep everything simple here, and with Python you can get very esoteric very quickly. So these are the main ones. Yep.
For like the input function, what's the default data type that it?
String.
String. Okay.
String. Yep.
So you have to when you do the input function, you have to verify that if you want numbers, you have to verify that, or you have to put.
Yeah, when we do the lab, I'll show you how that works. Yeah, the lab actually has input things.
Okay.
Okay. So that's the variables. So we go to page 11. Okay, page 11 is collections. So if you're new to programming, this will not be that complicated. If you're old to program, you're gonna be like, what? This is stupid. Anyways, so when you deal with most programming languages, again, C++, PHP, whatever else, you're going to have these things called arrays, right? You're gonna have an array. So it's either going to be a numbered array or what's called a named key array. And what this is this is a variable type that holds multiple values. So at index 1, it will be one value. At index 2, it'll be another value. At index 3, another value. 4, so on and so forth, right? I didn't realize this until I got into the Python world, but apparently arrays are much cooler than most of us realize. There's a lot of mathematical components that go into an array, again, to make math very, very fast. Again, that whole counting up to a billion deal. Anyways, what's curious with Python is they have this idea of collections. And so you have these different collections that look a lot like arrays, that have much of the functionality that we think of with arrays, but are not arrays. So again, once you start getting into very complicated math, you actually have to get an additional like array module. So there's either the array module or there's a NumPy module that allows you to use arrays. So highly complicated math, when you need arrays, there's actually arrays. But generally, in Python, you're going to be using these things called collections. And you have what are called a list, a tuple, a set, and a dictionary. So a list is basically a numbered array. So if you look down at the example down here for the code, you'll see list. So you use a square bracket. So lists open with square brackets. They can have numbers or they can have strings in there. Strings have to be surrounded by quotation marks. Numbers don't. The values are separated by commas. So you can see list 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 4, 5. So all those are all of the values in that list. So at index 0 is number 1. At index 1 is number 2. At index 3 is number 2, so on and so forth. So when you're looking at a list and you're looking at the numbering, the numbers start at 0, not at 1. It starts at 0. So basically with a list, you can do a lot of things with this. When it says ordered, basically what an ordered list means is every time you add a new value to the list, it goes to the end. So when I add a value, it goes to the end. It is mutable. What mutable means is that you can change the list. This becomes a problem when you deal with tuples. Tuples are not mutable, and there's a reason for that. It means you can change the values in the list, you can delete values in the list, the whole 9 yards. You can sort a list. And also that you can have duplicates. So as you see here, 2, 2, 2, 2, 2, 2, 2, you can have multiple of the same value, right? So anyways, that's what a list is, and you have the square brackets around the list. You then have a tuple. A tuple is ordered. Basically, it means there's an order to it where you add 1 to index 0, something to index 1, something to index 2, so on and so forth. You can have duplicates, so you can have the same number in multiple different places. But the thing is, it's not mutable, and this is going to be important. So a lot of times when we're going to be using tuples in Silicon Dojo, we're going to be using this for artificial intelligence projects. So especially with something like OpenCV, right? So if OpenCV gives you a collection back, and 1 is the X value, where something is on the horizontal. The next thing is the Y value, where it's on the vertical. And then you have height value and width value. You don't want to be able to sort that. You always want the X to be here, and the Y to be here, and the height to be here, and the width to be here. You don't want to be like, what if we reverse sort that? Like, no, what will that do? So anyways, that's why tuples exist and why tuples are important. So the immutability is an important thing. Then you have sets, which are weird. So tuples use parentheses around them. A set uses a squiggly bracket around it. The weird part about a set is that it's not ordered. Basically, the values go in essentially numerically or alphabetically. They just get plopped in, and there are no duplicates. So this can be very useful if you're trying to count how many unique items there are, unique values there are. So if you put 2, 2, 2, 2, 2, 2 in, it's going to keep 1, 2, and it will delete all the other 2s. So again, could be good, could be bad. And then you have dictionaries, and basically what dictionaries are is they look like named key arrays. So you use a squiggly brackets, but then you can do like name : Bob, age : 12, size : small. So that's what we talk about in named key array. And that's where basically what you're going to do is you're going to access the value by that name. So if I want dictionary name, it'll be dictionary square bracket, quotation marks, name, close square bracket, and that will give me Bob, right? So we go down here, and I show you, what's this called? Collection.py. So with this, just to give you an idea of what's going on, right? So we have the set. So the set is the first one. So 1, 2, 2, 2, 2, 2, 3, 4, 5. You'll notice when we print that out, it's 1, 2, 3, 4, 5. We get rid of all those additional 2 values, right? The dictionary, squiggle brackets, name Bob, age 12, size small. Name Bob, age 12, size small. The list, again, square brackets. We have the square brackets for the list. And then for the tuple, again, parentheses, and we have the tuple there. When we're trying to pull out a specific value, that is where you use the key. So with a list, you can use the numbered, right? So if I want the first value in the list, I do list bracket 0. This is going to give me the first value. On a dictionary, on the other hand, so this has no numbers. You can't do, like with arrays, you can still do 0, 1, 2, 3. You can't do that with Python. So if I want the name value in dictionary, I do bracket and then name. So if I print this out, I get 1 and I get Bob, right? So if I'm sitting here and let's say I want a specific thing for some reason, right? Let's say I want 4. So it's on a list. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I could do 8 here. And let's say I do age, just so you see how this works. It's the other nice thing too, like the IDE, it shows you that actually exists. And so we go here, and so that gives us 4, and that gives us 12. So that's how you access those indexes in a collection. Everybody get that? Yep.
For the set, you said it can be ordered. So
Yep.
it means, like when you add a value, it automatically puts it in.
No, so when you add a value to a set, unfortunately I don't have it in here. When you add a value to a set, it will numerically go wherever. So if I added, so let's say, right? So if I added the number 8, so if I added the number 8 to a list, the number 8 would go here. If I added the number 8 to a set, the number 8 would go here. So basically, it pre-sorts it for you. Which again, depending on what you're doing, may or may not be a good thing. Any questions on collections? Yep.
As far as the dictionary, what would be like a use case?
Oh, lots of use cases. So basically, again, if you want names, so like people's name. So again, one thing too, we're not going to get into it today, but you can have multi-layered collections. So, well, actually with JSON, I might get into it a little bit. But basically, so imagine you had a number of different students. So you could have a list of dictionaries. So student 1, name Bob. Student 2, name Sue. Student 3, name Tim. And so you could go to, I want the third student's name. So it would be like student, square bracket 0, square bracket, quotation mark, name. And that would give you, at index 0, that person's name.
Okay.
So that's one of the reasons you would use dictionaries. Again, as you get into Python, it'll be like, oh, that's why you do it. You'll see it. Yeah. Any other questions? Was that a question? No? Okay. So then we're going to get to methods. Oh, whoops. $13? Where did that go? Oh, no, that's 12. Sorry. Anyways, there was page 12. I missed page 12. If you want to add, this just gives you some basic stuff here just so you understand how this works. So like for list, if you have a list and you want to add a value, you do list.append and then whatever the value is, and that will add to the list. If you want to remove a value from a list, if you do list.pop and then simply the parentheses, that will remove the last value on a list. And then if you want to remove a value at a specific index, you can do list.pop, let's say 2, whatever the index value is, and that will remove a value at that particular index. So that's how you can either add to or remove from a list. If you're dealing with a dictionary and you want to create an additional value in the dictionary, you simply do whatever the dictionary name is, and then whatever you want the key value to be named, and then what the value is. So let's say, just to show you folks this. So let's say I do this. So I say dictionary, and then I do, I don't know, hair color, I can say equals brown. So basically, simply by declaring what the value is, that will create it. And then I can do print dictionary. And now all of a sudden we have the hair color of brown. So basically, if you want to add something to a dictionary, that's all you have to. Simply by declaring it adds it.
Go back to the code, please. I didn't see it.
Yep.
Thank you.
Yep. So simply by declaring it, right, that gets it. If you want to delete it, so you do del dictionary, whatever the key is, and that will delete it. If you want to update, I guess that's not here. If you want to update the value in a dictionary, all you would do is you do dictionary, the key name, and whatever the value is. So, blonde. So that's how you're able. So I create it. Initially it's brown, and then I change it to blonde. So it's pretty simple. Yep.
So for a set and a total, can you use the independent operator?
Those were, I don't know why I just put list and dictionary. You don't use sets and tuples a lot. So we're going to, again, ChatGPT on that one. I'll add that to the class later. It's one of those things, I'm like, I'll leave those out. And then it's, because the thing is, like what you have to understand with Python, why this is complicated is with Python, there's very specific syntax. So I do believe with sets, I do believe it's a different word. I think it's like add. I think it's like when I looked at it, I was like, oh, that's just going to be a little bit more complication. So that's why I left it out. Okay, so let's look at, everybody kind of sort of get that? Sort of. Okay, then we're going to get to concatenation. So don't worry, we've got a little bit more, then we'll get to labs. A couple more pages, then we'll get to the labs, and we'll get to start working this out. So basically concatenation, what we're talking about with concatenation is we're going to be taking dynamic variable values, and we're going to be adding those to static strings. So let's say we want to say hello, but instead of hello world, what if we want to say hello, whatever the username is for the user account? So it'd be hello, and then the value for the username. If we take a look at this, basically there's a number of ways to do concatenation. The right way, and the way that going to make your life a hell of a lot easier, is this thing called an F string. I do believe in JavaScript they're called temporal literals or something. Anyways, we've got F strings in Python. Basically what an F string allows you to do, and so this is something new to Python 3, as in it was created like 10 years ago. So it's new, but right. So, but that might be an issue, right? If you're using some really, really old server, F strings might not be available on it. So just kind of one of those random things to keep in mind. Should be, but anyways, so all you do with an F string is you do F and then either single or double quotation marks. And then inside, wherever you want the variable value to be, you do the squiggly bracket and then whatever the variable name is. So F string message space name. So that's world. Anyways, so I could do Bob here, right? I could do Bob. So what this will do is it'll say hello Bob. Like you can type in other stuff in the middle here. So you can say you are logged in as Bob, as, right? So you can do something like that, right? So hello, you are blah. And so when you run that, right, that is then going to take the static text that you have, and it's going to add those dynamic values. So again, with numbers, with names, again, you're going to see this a lot as we do different things. So that is going to be the main way that you're going to do concatenation, and it's about the only way we're going to do in Silicon Dojo. But since we're doing a class, I do also have to show you the other ways. So you can either use pluses or commas to also do concatenation, and that's where you get this mess. So basically, with whatever is going to get concatenated, you have to put it within parentheses. So message and name, you'll notice those are in parentheses. And then if I want to do exclamation marks, I have to do parentheses and then the single quotation marks around that. So this is where you start to get, so basically you can end up with the same thing, it just takes a lot more text in order to get it done. So you can do the pluses or you can do the commas. Now when you do this, one of them is going to give you a space in between and one is not. Okay. So when you do pluses, it will not put any spaces in between, so everything gets scrunched up. When you do commas, it will automatically put the spaces in between. Yeah. So this kind of thing you might see in some, again, when you go to copy paste code, you're going to go look at labs or demonstrations from before. You may see concatenation like this. I just want you to understand what the hell this is. Just stay with it. There's almost no reason not to do f strings though. So that's what we're talking about, concatenation. The other thing too is with triple quotation marks. So let's say new message equals, this is a comment on multiple lines. So generally, whenever you're doing your strings, everything has to be on the same line. If you open with 3 quotation marks, double or single, and close with 3 quotation marks, double or single, basically you can put things on multiple lines. So this might be important for when you're creating HTML documents or such. So basically with those multiple quotation marks, that allows you to put things on multiple lines. Just one of those things to keep in mind. Again, you'll start to see more of this later, so you understand what's going on there. Okay, any questions there? I do realize with the variable names, or the variables, I did forget something when I was doing all this, so there's something called naming conventions. Again, when we start talking about styling versus syntax, you can name your variables whatever you want as long as it doesn't conflict with something else. In the technology world, or in the coding world, there's basically 2 different naming conventions. One is camel case, my variable name. So C++, I think this is for JavaScript. Basically the idea is when you have multiple words in your variable name, whenever there is a new word, you uppercase that word. So my uppercase variable, V uppercase N, right? In Python, we use something called snake case, or yes, snake, whatever. Anyways, what this is, everything is in lowercase, and then when you have a new name or new word, you put an underscore. So again, basically this is just a styling thing. Camel case will work in Python, and then people just will scoff at you and will not hire you. But anyways, so that is a naming convention. I do realize I forgot to bring that up. Okay, so we got concatenation. Then we get to methods. Methods. So basically what a method is, it is a way to modify a variable value relatively easily. So one of the big things to understand with variable values or values in programming worlds is sometimes capitalization matters and is very important. Other times capitalization does not matter. And sometimes you deal with systems where some parts matter and some parts don't, where you get to be a complete disaster. So when you're dealing with the Windows world, this is a very important thing, again, especially if you haven't dealt with systems administration. If you're dealing with the Windows world and you're dealing with like file names, all uppercase is the same as all lowercase, is the same as mix of uppercase and lowercase. Those are all the exact same file. If you do Linux, those are all completely different files, right? So you can run into problems there. The other thing is like with variable values, right? B, uppercase O, lowercase b, this might be the same value as everything being lowercase or different than everything being uppercase. It depends on the programming language that you're dealing with. So one of the things that methods allow you to do is basically it allows you Oh, to sanitize variable values going in and basically make them all one way. So if you're dumping everything in the database, everything that goes in is going to be uppercase, or everything that goes in is going to be lowercase, or everything is going to be something, right? It's always going to be that thing. And that's where basically you have here, where you have like Bob, and we're going to say print name.lower. So the lower method will make all this lowercase. The upper method will make all of this uppercase, and the title method will capitalize the first letter in every word in a string. So if we do this, basically what we see here is we go from Bob to Bob to Bob to Bob, right? Makes life a lot easier. And this can be very important too, again, like with logging into systems. So we're in 2026, so you shouldn't run into this anymore, but you still might. But if you go back to 2015, like I had an account with one of my providers that was like 10 years old, and literally it was the most frustrating thing, because when I logged in, I had to use the same uppercase on my email address, because if I used a different case, it failed. And so literally what you can simply do is when the email address goes in, you lowercase it, and then you test that against everything lowercase in your database so that it makes it easier, right? So anyways, things to be thinking about there. The other thing with methods is that basically you can use them, again, as I said before, to modify the variable values. So like a big thing that we're going to be dealing with a lot of times when we're dealing with data is something called CSV files or CSV data. What this is comma separated values. So basically, if you open up like a spreadsheet or something, you may see like everything is just separated by commas. Or if you export data out, everything is separated by commas. That's comma separated values. When I import that into Python, it's going to be a string though. So when I say attendance equals Bob, Sue, Tim, Pam, and Tim, you notice there's no brackets. There's no square brackets, squiggle brackets, parentheses, or anything else. So this is a string. So what if I want to be able to deal with this as individual values? That is where I can use this split method here. And so what I do is I say attendance equals attendance.split. And what I'm going to do is I'm going to create a list, and I'm going to split the values here wherever there's a comma. So Bob goes to 0, Sue goes to 1, Tim goes to 3, Pam, so on and so forth. So if we print this out, see, we can see here where this was the initial string, and now here we get that list. So that turns into a list. And so that can be very valuable. There's other methods. Again, you can Google search methods, all kinds of methods out there. Like there's methods to replace. So let's say there's certain text within a string and you want to replace that text for some reason. You can replace the text. You can strip out white space if you want to strip out white space. There's a lot of different methods out there. And the important thing is to understand what methods are and that they exist. Anyway, how are we doing with that? Good? Okay, now we'll get to loops. Loops and conditionals, page 15. What's that? Bathroom break. If you need a bathroom break, can you do like 10 minutes, 5 minutes? I mean, if you can't, you can't. You can? Okay. Yeah, because we're going to do labs or just in a couple more pages. We got loops and if-else statements, and then we're there. Okay. So we're going to do loops and conditionals. So basically what loops are is you just continuously run a process until a condition is true, right? So we have conditionals. So what conditionals are is equals means equals to. Exclamation point equals means not equal to. Less than equals means less than or equal to. Greater than or equals means greater than or equal to. So basically we're going to do a loop until that condition happens to be true. So we take a look at this. Do I not? There I did it. Okay, good deal. So we have this. So in Python, we only have two loops. We have while loops and we have for loops. So again, other programming languages have something called do while loop. We don't got it. We just got the while and we got the for. So when you have a while loop, you're initially going to set a variable, and this is going to be like this is simply being set to 0 now, just to give me something to iterate by, but this may be set somewhere else. We'll deal with that in our lab environment. And so all we have here is while x is less than or equal to 5, and then we do colon. So this is going to be the opening of our statement. And then we're going to come in. So in Silicon Dojo, we just do tabs to make life easier. Per PEP 8 standards, it's supposed to be 4 spaces. Anyways. we're going to say print x. So while x is less than or equal to 5, we're going to print the value of x. Then we're going to iterate up. So in Python, you can do x plus equals. So what this is x plus this value, x equals x plus this value, right? That's how it works. And then you're just going to iterate up. So what happens here is, right, it counts from 0 all the way up to 5, and then it stops, right? So the big thing to be thinking about with these while loops is to make sure at some point the condition actually equals true, right? You can do something stupid, where basically the condition of a loop never gets to be true, and then it's just a continuous loop, and then your server crashes at some point and everybody cries. So let's say we do this. Let's say 4, and we say x equals 5. X equals size. So x equals 0. Let's see, no, while x does not equal 5, sorry. So while x does not equal 5, like we're just going to iterate up. We're just going to go up. Right? But we're just going to go by 4 for some reason. So while x does not equal 5, print x, and we're going to say x plus equals 4. So again, imagine these are dynamic numbers that are coming in, and so you didn't realize what the user was going to put in. Like notice how many times you guys ask me questions, and I'm like, oh crap, I didn't think about that, right? That's what being a support person is like, right? So if I do this, so it's going to print x, it's going to plus by 4, and the thing is, it is never not going to equal, right? And it's just going to keep going on forever. So that is where you do Control-C, Command-C, stop. There you go. And so that's why you want to do this, because as soon as it goes over 5, it'll stop. So that's a big thing, is always make sure you put that limiter. That's one of the things I talk about, especially once we start doing API calls. So that'll be something we've talked about in other classes. What an API call is where your script goes to somebody else's server and pulls information back. Well, we're going to use a lot of free APIs, so it doesn't really matter. But if you start paying for the API calls, it may cost you a fraction of a cent every time you make an API call. But if you have a continuous loop that works at that speed, imagine if you were getting charged a fraction of a cent as fast as you saw those numbers go by. That sucks. So anyways, that's where this stuff gets to be really real. So anyways, there's that. The other thing that we have is a for loop. And so basically what a for loop is for is through iterating. So when we talk about iterating, it's every time we go through a loop. And so let's say we have one of these collections. So we have a student list, Bob, Sue, Tim, and Phil. So what a for loop is we say for, we create a variable name for the index here. So we say for x in student, and then we do something with that variable name that we create. So we're just printing that out here. And basically we get a for loop. It's just going to go through and it's going to print Bob, Sue, Tim, and Phil. Right? So imagine this was email or whatever, right? If I did that F string, F, and I could say like, hello. Right? Now it's going to go through. And again, imagine that's an email, some kind of news blast that's going out. Every time it goes through, it would then fire off that particular function to send out an email, an SMS message, or whatever else. Kind of understand what's going on with loops there?
Can you go back to the code you just
Boop. So we're doing an F string here like we talked about before. So hello, squiggly bracket, the variable name. And again, with this variable name here, I can name this whatever I want. It doesn't have to be X as long as I use it throughout the code. Yeah. And that is where you're going to learn the real fun of being a technology professional or coder, is coming up with variable names. Oh, you think it's all like science and fancy math. It's really about variable names, especially when you get really big pieces of code. Anyways, okay, those are loops. All right, final thing, if-else statement, and then we get to the labs. Okay, so basically if-else statements, this is what we all think of when we start thinking about programming languages. So basically with an if-else statement, what you do is you say, if something is true, do something. In the Python world, we use elif. So again, this is one of the big problems with programming languages. Most programming languages do 99% of the exact same thing. They just have like 1% that they do really specially. The bigger problem is the syntax. right? So some programming languages say else if. In Python, it's elif. So most of the time is literally just trying to figure out what word you're using. So anyways, what we do here is, so this is an if-else statement, right? So if age is less than teen, so what we're going to do here is, so this is going to be the input, right? So while true is going to be a continuous loop. So age equals that input function I talked about before, your age. So I can put in whatever my age is. When I do that, though, it's going to be a string. Remember how it auto-assigns data types? So with the input function, it's going to auto-assign it as a string. I don't want that. I want it as an int. So if I put 12.5, it's just going to be 12 because it's an int, a whole number. So age equals int of whatever age is. So if age is less than teen, so teen is 11, print you are a kid. If age is greater or equal to 11, right? So make sure there's no gaps there. And age is less than 18, you're a teen. If age is greater than or equal to 18 and age is less than retired, you're an adult, else you're old, right? But the important thing to be thinking about here is make sure you cover all the numbers, right? If less than teen, so less than 11, right, then you're a kid. But see, if age, if I just did this, is greater than 11, well, if I'm less than 11, I'm a kid, and if I'm greater than 11, I'm a teen. What happens if I'm 11? It's going to be an else. So you're going to say I'm old, which, I mean, for an 11-year-old, really, yes, I am. But anyway, it's not going to work out well for you, right? So, because yeah, let me see if I run this right now just to show you. Right, so if I say 44, right, you're an adult. Literally, if I say 11, it's going to say you're old because it's going to be the final else. The final else is if none of these conditions are true, that's what you're going to do, right? So that's where, again, this is where I talk about, like, with being a coder or being a technology professional, it's not about being smart. And I'm not saying this to placate people, it's just true. It's about precision. So anyways, so what you can do is you can do the and here. So it's like you can do the one condition or you can do multiple conditions like that. And that's what gets you the if-else statement, right? So if you go through, you know, if I'm four, you're a kid. I'm 66, you're old, right? So you can go through and play. I will show you if I do TT, it'll error out because I don't have any correction mechanisms in there. The other thing is you can do strings. So elif with password.
Is it on topic? What would you do to make a correction and say this can only be, input can only be the int?
Oh, I will get to that in a second. I want to make sure she can go to the bathroom. So I'll just finish this and then we can go. Okay, so with this, basically password, we're going to have a password equals open potato. So while true, you're going to input your password. Now you notice I'm not going to change the data type here. So if password is in the phrase, print you are right and break. Else, so you're going to break out of the script. Else, print you are wrong, try again. So if I run this and I say hello, yeah, I got to be careful with that. Hello, potato, right? Oops. That wasn't supposed to be. Yeah, anyway. If I do hello, oops. Oh, did I do not?
Yeah.
What was I doing there? Anyways, is that in there?
No, it's not.
Oh, I must have been fucking. See, that's the problem when you're screwing around with your own code. Anyway, so I can do hello, potato, right? You are wrong. And I can say potato, you are wrong. And I can say open potato. Please, you are right. Gets out, right? So basically what this is doing here is what it's looking for is if this, what's called the substring, if this substring is within this string, this is what will happen, else this other thing will happen. So you can either do in, or as I was showing you before, not in, and depending on the thing, that's how it will work out. So anyways, okay, so that is that. So
2 questions on that.
So if you need to go potty, you can go potty now.
Is
Yep.
that case sensitive, the open potato?
I do not believe it is. Here, let's see here. Open potato. Oh, yes, it is case sensitive.
And if you type in open potato number 2, because you contain open potato, but then you're adding more stuff.
Yeah. So you are right. So yeah, since open potato, again, we are just massively simplifying things right here. But like, so yeah, so like with what you're saying, so what I could do is I could do if phrase dot lower. Oh no, if I did, oh no, yeah, phrase. Yeah, dot lower. All right, so then I could run this, and I should be able to open. There, you're right, because then it is lowercasing it, and then it's true, right? So that's where you can use the method for that sanitization process. Yeah. Cool. Okay, when people get it back, I'll explain these. Well, I'll explain the labs to you, and you can start working on the labs. And then when the other people get back, they can work on the labs too. So the first lab that we're going to be doing is the guessing game lab. So this is, you are going to be writing this out on your computer, and hopefully it will be working right. So again, one of the big things in the technology world is everybody wants our jobs. Nobody wants to do our work. It's a funny thing. They're like, I really want your paycheck. I don't want to do what you do though, right? It's like, well, there you go. So one of the reasons we have labs, and again with Silicon Dojo, it's really important to actually do the work, because you have to get the muscle memory down for the commas and the semicolons. You have to get that memory down so that when you look at code, you're like, oh, that looks wrong. And so if you don't actually do the process, it's not going to work. Anyways, so basically what this script is a guessing game, right? So what it's going to do is it's going to create a random number. When I run this, it'll say, what's your guess? And so I'm going to say 7. Say, your guess is too low. Then I'm going to say 10. Oh, 10 is right? So if I run this again, let's say your guess is 4, your guess is too low. I'm going to say my guess is 10, your guess is too high, 6, your guess is too high, 4, guess is too low, 5. There we go. So we got a nice little guessing game. Can you guess the number? Pretty simple here. Again, goes through a lot of what you have before. So we're going to import a function from a module. We're going to create a variable called number. We're going to assign that variable a random integer between 1 to 10. So one of the important things to be looking at is how these scripts are written. This number is going to be assigned outside of the while true loop. If I put this inside the while true loop, every time the loop runs, it's going to reassign the number. So we want to assign it outside the loop. While true loop is going to go on forever. It doesn't really matter because, again, you're not going to get charged for this. So guess equals input, what your guess is. Guess is then going to equal, you're going to turn that guess into an int. Then what we're going to do here is if guess is greater than number, print f string, what the guess value is too high. If guess is less than number, f string, guess is too low, else, hopefully it should be right, print your guess is right, and we're going to break out of the loop. So basically this is giving you the module, this is giving you creating and setting a variable value. We're doing a loop here, we're doing the input, and we're doing an if-else statement. So that's the first lab that you guys need to do. And the second lab that you need to do, to be clear with this, I have no idea if this math is correct. To be clear, I'm an IT person. I'm not here for the math. So what this is supposed to be, nope, don't do that. So Command Z or Control Z undoes what you did. Anyways, so basically what this is going to be is it's a loan repayment system. Again, how good the math on this is, who the hell actually knows? So what we're going to do here is owed equals, and then we do the input starting loan, and then I'm simply going to put that within the float function. So again, one of the things I want you to understand with coding is you can do the same thing multiple different ways. So with this, I'm going to get the value that comes in, and I'm automatically going to turn it into a float, so a decimal point number. Right? Payment is how much I'm going to pay every month. What my monthly payment is going to be turned as a float. Interest is also going to be turned in as a float. So what my yearly interest rate is. Now you got to think about the math. So if you have a yearly interest rate, 12% per year, what does that mean per month? So I don't know, something along these lines. So interest underscore monthly. So we're going to use that snake case equals interest divided by 12. So let's say 12, whatever, divided. So it's 1% per month divided by 100. So when we do the math, we need a decimal point. So if I put in 12, I don't want to multiply by 12. I want to multiply by 0.12. Right? So that's where the divide by 100 comes in. And then we're going to say month equals 0 here, so we have something to iterate against. While owed is greater than or equal to 0, we're going to print the amount of money that is currently owed. Owed is then going to equal owed minus the payment. So we're going to subtract the payment that comes in. And then we're going to do owed equals owed, so the amount, plus owed times the monthly interest. So after we subtract the amount, we're going to take the amount that's left, we're going to multiply that by the monthly interest, and we're going to then add that back to owed, and then we're going to say month plus equals 1, so we're going to iterate up 1. Right? So we're going to print out the owed every time this goes through, and then finally when we break out of this loop, months to pay off equals however many months. So when we run this script, all right, so I'm going to say I owe $100. Let's have a monthly payment rate of 12. I'm going to pay 12 per month, and I have an interest rate of, let's say, 10%. So it's going to go through, it's going to iterate. So the first time I owed 100, then 88.7, then 77.3, so on and so forth. And so it's going to tell me it's going to take 9 months to pay off. Again, just to prove that this code does not have fault tolerance. So let's say if I run this code again, let's say I owe $1,000. My monthly payment is $5, and my yearly interest is 20%. Then we get that mess. Again, one of the things you have to be thinking about is whenever you're going to write the code is putting in something. So if the user, basically, if the condition is never true, at what point does it fail out? That's something you can think about. So like what we could do here, if you cared about that kind of thing, and you can do extra credit, right? You can say while owed is greater than or equal to 0, and month is less than 300. Like we don't want to get payments past 300 months. You could do that kind of thing there, add some functionality. So anyways, those are the 2 labs, and I will give you, holy shit, it's 11:18. Anyways, let's give you about 20 minutes for those. And then we'll keep, actually it's not too bad. We'll give you 20 minutes. If you need 30 minutes, we'll give you 30 minutes. Any questions on that though? Questions? No? Okay. And do remember, you're here to tippy tap. Tippy tap type. Okay, everybody ready? Let's get through some stuff, and then you guys can have some lunch and decompress. Okay, so one of the big things with modern programming languages, so we talk about things like architecture. So if you ever come to my classes, I always talk about architecture. I love me some architecture. Again, I am a systems engineer from Windows NT 4.0 from 2000. I love how systems get built. This coding stuff is for coders. Anyways, one of the interesting things with systems in the modern world is one of the things you'll hear about is something called service-oriented architecture. So back in the old days, we used to have client-server architecture, and the idea is you have a server with a particular piece of software on it, and you have a client computer with a particular piece of software on it. They are both configured to be able to communicate with each other properly. So again, things like email services. So like back in the day, if you had Outlook and Exchange email server, Exchange and Outlook also had things like calendars and appointments and all this kind of stuff, and they knew how to talk to each other, and you actually had to set everything up so they could talk to each other appropriately. One of the interesting things we get to with service-oriented architecture is we realized that crap was for the birds, because when you get married to Microsoft, Microsoft is a very abusive spouse, right? You always have to be able to tell your vendor that if you don't start screwing around, I'm gonna walk, right? But you get with Microsoft, you can never walk. Anyway, so that's where you get the service-oriented architecture. The idea of service-oriented architecture is instead of your systems being tightly bound to one particular server, that you should just have a little snippet of code and basically swipe your credit card, and if somebody starts doing something stupid, all you have to do is swap out that little bit of code and that little bit of credit card transaction and go to somebody else. So let's say Twilio, right? So back in the day, like I actually used to have to build my own voice over IP servers, right? If we wanted voice over IP in the enterprise, we actually had to build a server. We had to deal with trunk lines. We had to deal with all this mess. What's amazing nowadays is if you want voice over IP for your application, you go to Twilio, you swipe your credit card, you get 5 lines of code, you got voice over IP. Now here's the thing with that, is if Twilio starts doing something stupid, so I've heard a lot of people that don't like Twilio, I'm not getting that argument, so you decide to leave Twilio, all you could do is you find a different vendor with a service that you prefer, you create an account with them, you swap out a couple of lines of code, and now all of a sudden you're using that other vendor, and it's basically relatively easy. So that's what we talk about when we talk about service-oriented architecture and why it's so cool. So one of the big things with applications is you're going to be using something called APIs, application programming interfaces. Where's the wand going? Anyway, application programming interfaces, and this is how your code interfaces with their systems. So this is one of the big things with everybody tries to reinvent the wheel. Stop. It's a wheel. We got a wheel. Just leave the wheel, right? And so when we start talking about application programming interfaces, a lot of people say, well, how can I do this thing that they didn't document? It's like, you don't, right? Because basically what happens is they have, so basically what happens with the thing, all right, is so you're over here, right? You're over here. You got your computer here. You go up to the cloud, and they have their infrastructure over here. And it may be really, really complicated, or it might be running on Raspberry Pi 5. You have no idea. Because basically what they do is they open up what is called an API. And what that API does is it says how you are supposed to talk to them. This is how you say hello to me. This is how you make a request. This is how you tell me, you know, whose credit card I should bill, that type of thing. That goes into the API, and then basically formatted, you'll hear like things like structured data. So essentially you're going to get a structured response back, and that is going to be something that your computer can parse. Right, so that's what we're talking about, service-oriented architecture, and we're talking about APIs. So when you're dealing with APIs, there are a lot of different APIs out there. The big API that we use a lot, standard, is something called REST. And I don't know, that stands for something. Representational, whatever. We just call it REST. It's called a REST API. Basically, with a REST API, what's going to happen is you are going to make a request to their API, and it's going to look like a get value. So you're going to say like whatever their domain name is, right? And then basically there's going to be a question mark, and you're going to say something like weather equals today. All right, and so what it's going to do is it's going to go to their domain name. When it goes into their API, it's going to say, okay, you want a value for weather, you want it for today, and so then it will send back a JSON value that will tell you the weather for today. That's basically what we're talking about with the REST API. There are a lot of free REST APIs out there. There are also a lot of APIs that cost money. The one thing that I will tell you is be careful, especially if you use GitHub and you're using APIs that cost money, is so there's something called an API key. So a lot of these APIs are completely open. You can just hammer the crap out of them. Who the hell cares? Some of them, they require an API key, and so that is the identifier. That is the identifier that says this request is going to this account. If you put that into GitHub, there are hackers out there that 24/7 scan GitHub looking for API keys. And so if all your API key is just like some of these API keys, all they do is they limit you to, it's still free, but they limit you to a reasonable amount. Like you can do 100 requests per day, right? Worst case scenario, they're going to use all your requests, boo-hoo. Worst case scenario is you get charged a penny every time there's a request. some hacker gets this thing and does a while true loop, and you get a $5,000 bill. So do be careful with your API keys, with REST APIs. So basically, when you're going to be doing REST APIs with Python, the first thing is you are going to need to install your first module. So there's something called the requests module. This is a completely, utterly normal module you're going to use on damn near every project. I have no idea why it's not part of the core when you download it. It's just not. You do have to install it. So you do Python --m pip install requests, and that will get you the request module. What the request module does is it allows your Python script essentially to make HTTP requests. So that's the protocol language for going to websites, and so that's what allows you to do it, right? We are going to be using right now this particular REST API called ip-api.com, which is very useful for dynamic applications. One of the big things I see with teaching people how to code is the more dynamic you can make projects, the more interesting the projects are, and the more likely people are to keep playing with them, right? If you have a static code, it gets really boring really quickly. So having something dynamic is kind of fun. So what's cool with this REST API is basically what it's going to do is it is going to return a value. So this is something called JSON, JavaScript Object Notation. Anyways, it's going to look like a dictionary. You start with a squiggly bracket, you close with a squiggly bracket, and then you have these named keys, right? So a status of success. And then basically what this is doing is it's checking what your external IP address is. So when your computer goes to the outside world, there's something called an external IP address. That external IP address, information about it is sitting in databases all around the world to tell everybody about you, right? There's this whole idea about things like cookies and all that kind of stuff. Oh no, cookies, right? Everybody's worried about cookies. Cookies is so 1995. Anyways, it's like, why would you? It's funny, like they start outlawing cookies at the point that cookies become obsolete, which is about how governments work out. Anyways, so the external IP address for this place is 136.41.224.92. And so basically there's all of this information sitting in databases around the world about this particular IP address. It's in North America, it's in the United States, has a country code, region North Carolina, city of Raleigh, again, reasonable accuracy. It gives an approximate zip code, a latitude, a longitude, Google Fiber, it tells me what the ISP is and all this kind of information, right? So one of the cool things you can do here is you can start, you can dynamically have your code give responses based off of this type of information. So one of the labs that we're going to do in the afternoon using Ollama, so Ollama is an LLM framework, is basically you're going to be able to say, who was my president in 1900? It's going to find out where you're located. It's going to find out you're in the United States or you're in Argentina or whatever else, and then it will respond based off of that. So if you're in the United States, it'll tell you, I don't know, Theodore Roosevelt, maybe? I don't know. If you're in Argentina, it'll tell you whoever the president of Argentina was, right? It starts giving that dynamic information. So like here, if I go up and I turn on my, turn on my VPN, right? And let's say I click on Argentina. And I go back here and I refresh. There we go. See, now it's saying South America, Argentina, Buenos Aires, and the whole 9 yards. Right, and so this is a very, 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 very simple REST API that we're going to be dealing with. So what happens is, wherever my code is, so we got this first. So first we need to install the request module. If you run this and it completely fails out, you probably forgot to install. So on your system, you have to install, or within your virtual environment. So if you're using a virtual environment, make sure request is installed there too. So import request. Then we're going to have a URL here. So URL equals, and this is going to be the API call, the API address that we're going to be going to. Notice there is no S here. Again, depending on the service you're using, if you try to use S, it will fail out because they don't use S for whatever reason. That's SSL. So response equals. So we're going to do the request module, the get function, URL. So the URL we're going to put in there. And then we're going to do .json. So if we just do this, it's going to come back as an object. And if you print it out, it's going to give you like the arrow brackets and some object crap in the middle. It's not useful. So you can either do .text, and it will come back as text, just pure text, or you can do .json. And so when it comes back as .json, it basically comes back like a collection so that we can interact with it. And so here, I'm simply going to do print response, and it's going to print everything out. So this is actually coming into my code. And if we take a second, come on, work for me. Work for me. There, whoops. There we go. So this is just showing you, this is all now within my Python code, right? Status equals success, country equals Argentina, so on and so forth. Right, so what I could do here is country. If I want to do, right, so I have this F string down here. You are in this city, response city, right? So basically, the response that comes back at the city index, since when you're dealing with JSON and there's named keys, it's just like dealing with the dictionary. So city, basically, if we print that out, you are in Buenos Aires, right? So that's how you get those individual values out of there, right? Pretty simple. And again, if you're trying to figure out what keys to go for, you can print out the entire response, and then you're looking, so it's a key, what's called a key value pair. Key country, value Argentina, key region name, value Buenos Aires. So basically, you would be putting the key value in there to pull that information out. Let's see here. Then, one of the things we can do here is if we want both the key value pair, we want to loop through for whatever reason, we're going to use this items method here. So we're going to say for key, comma, value. So this is a variable name for key. So it could be whatever variable name you want. We're just going to call it key to make life easier. Comma, whatever variable name you want for value, again, to make life easier. And then in response, but now we're going to do dot items. So that's actually going to get all the keys and values out. We're going to do an F string here. So we're going to do F. We're going to print out the key, then space hyphen hyphen, and we're going to print out the value. All right, so we can do that. And there we go. So basically, these are all the things, right? Status comes back as success. Country is Argentina. Region is C. Blase, blase, blase. Does that all make sense to you?
So that last for loop that you did, that's basically just formatting the response that you're getting back?
Yeah, so it's just giving me that particular, so, yep. Yeah, so like with this, that's where you could do, again, and this is all how you decide to do it. So key value, right? So static with dynamic. And so now C key value. Yep.
What did you do? You get Argentina instead of me get a value?
Because I'm using the VPN now. So I went to the VPN, that's why I'm getting Argentina. Yep. Okay, everybody got that? Yeah. Pretty simple. It's all pretty simple. Now the next thing. So this is a little confusing if you don't pay attention. So pay attention for half a second. Okay, so there's something called the JSON module. So you'll notice doing everything we did up until this point in time, we did not need the JSON module. This is just normal Python stuff. Anyways, the JSON module is a core module. You do not have to install it, but you get some fancy functionality if you import the JSON module into your code. One of the problems that you're going to be dealing with is sometimes, again, you're going to be getting these responses back and you don't know what the hell to do with it, right? So what I just showed you was a very simple response. Again, it's a pretty small response. It's very easy to figure out what's going on. Sometimes these responses you get back are just going to be monsters. And so again, if you're trying to figure out the exact index you're going for, it can be very difficult. So that's what's cool with this dumps function. So the JSON module dumps. You can put in the JSON value, and then you do indent equals 2. And so what this is going to do is each level of the JSON is going to indent by 2. So basically, when I print this out, now it's going to look like this, right? So it opens the bracket, it goes in 2, and then it shows me status, country, blah, blah, blah. Because the important thing to understand here is within here, there could actually be a list, right? So anybody here that's been in the AI classes we've done before, I showed this with, there's a REST API for dealing with country information. So something like the official name of a country, they might have 3 official names. So you might have like official name, and then within that will be bracket, and then 3 different names there. That's how you start layering, right? So anyways, by doing this dumps, This is giving you a string value that is formatted so that it is easier to understand what it looks like.
Sorry, what was that indent part?
So the indent, so if we look at the, where is it? So we look at indent 2, the indent is indent 2. So if I said, basically every level will be indented by that amount. So if I said indent 10, all right, see how it opens there and then goes over by 10. So basically every level you go by 2. So again, that's just up to you. The default is kind of 2. The big thing to understand here though is that this is a string. So if you okay, and then you do a response. Oops. So if I try to, come on. So basically here, right, if I say response equals JSON dumps whatever else, this JSON dumps function is going to turn this into a formatted string. It is no longer going to be a JSON data type. And so when you run this, it'll fail out because a string doesn't have indexes. So that's one of the things to be careful, because what happens a lot of times, especially when you're first playing with this and learning this, is you're going to use this function a lot just to figure out what the hell you're looking at. And it's very easy to go, oh, I just want to keep that formatting and then be able to interact with it. But this creates a string. It's no longer JSON. Yep.
Indent, will it run?
If I get rid of the indent, I don't think so. Maybe. Again, the questions people ask. No, because it's still a string. Yeah, when you, because basically, if you do print type, oops, print type. See, it's a string. It's been turned into a string. Anyways, so that is the basics of JSON and REST APIs. Again, this is one of those things you're going to be using a lot. Yep.
So that is just for your reference if you're trying to make sense of whatever data you about to parse.
Yeah.
Okay.
Yep. Yeah. So for you or like documentation, basically, yeah, it's a way to create a human readable representation of what's going on. Yep. And then if you look at the if you look at the bottom of this page, you'll notice there's a hyperlink there. Again, if you go to that, you will see this goes to a GitHub page. What? Oh, weird. Public? I don't know. APIs? The hell is it supposed to be? Of course. Public APIs. Oh, there we go. Okay. So it should be public space or hyphen APIs. And if you come here, these are all kinds of REST APIs that are basically completely free. And they've got a lot of different stuff here. So everything from animal information to art to books to cryptocurrency to events to finance. So again, if you want to get some dynamic information to make it a little bit more fun to play with, you can come here and start playing with some of those REST APIs. Okay, any more questions on JSON? So that if you look at the bottom, so it's on page 22, and so just make sure it's public hyphen APIs, and that gets you to the thing. Okay. Yeah. When I clicked, for whatever reason, it cut off that APIs part. Any other questions? Cool. Okay, let's do try except statements. All right. So try except statements are going to be an important one in the coding world, in the Python world. Please tell me how my try except. There we go. Okay. So as I've said before, one of the big problems you have, well, I guess one of the problems you have with Python is as soon as the code fails, as soon as it runs into an issue, the code exits. right? As soon as you make a mistake on a variable, as soon as there's an error of any type, basically the error pops up and the Python code drops, which is a real issue. If this is supposed to be running 24/7 and you get some weird ass little blip, you don't want the entire code just to flake out. So that's where we have these try except statements. And so this is one of those things that I'll say for anybody who comes to Silicon Dojo classes and you look at our code and you're like, shouldn't there be some try except statements in here? It's like, yes, there should be. If this goes into production, there should be. But again, in Silicon Dojo, what I'm trying to do is I'm trying to focus on the very specific topic that we're talking about that day, so I don't care about errors. But if you do care about errors, try except statements. So basically what the try except statement does is it tries to do something. Basically, the very basic part of it, all you need is try and accept. Try to do something. If it works, it works. Except if it doesn't work, do something else and keep moving. That way, the Python code is never in a condition of failure. Because if this doesn't work, it knows what to do next, and so therefore it keeps running. Right? So that's basically a try except. So basically, if you try to connect to this REST API, maybe you screwed up the URL, maybe the API is down. Because again, especially with a lot of these free APIs, they're a bit flaky. Like when they work, they're great, but they're flaky as hell. So if you're constantly pinging their API and then they're down for some reason, right, that's going to be a failure. So you can have an accept, and the accept might be response equals service is down, that type of deal. But basically, if you take a look at it, so you can have try, so that's run the code. Then you can see down here under the here, accept, exception as E, or whatever variable name you want. So depending on what you're interacting with, you might actually get an error code that you might care about. Again, do you care about the error code? Who the hell knows? But if you do care about the error code, this is how you can get that error code and do something with it. So basically, you can print out the E, so you can print out what the error code is. You can also just do accept. So accept is just there's an error. You don't care what the error code is. And so you do this. Else, so this is kind of weird. So what else is in a try except statement is if the try works, then also do the else. Right? So if my request goes to the REST API and I get a response back, else input that response into the database. So I don't want to do an input action if I didn't get a response, right? So that's where you put the else. Then you have a finally. Finally always runs. Whether it works or whether it doesn't work, it always runs. So we take a look at this right now. And so, yeah, so basically what this is, we're doing the JSON as we did before, response equals request.get url.json print response city, right? So if I run this, it should work, right? So we get Buenos Aires, then we get the else runs when the try works, and then we get the finally always runs. Pretty simple, right? Now what if I go up here and I put 2 hyphens in, right? So put too many hyphens in. So now when I go to run this, right, you get the error. So error, this is the HTTP connection, so that print out the error, and then you get finally always runs. So now this is printing out what the error is, and we get the finally. So this is essentially what we're doing with try except statements. Yeah. What's that?
So you don't have to go through like every line of what was wrong and tell you.
Yep. And it's also good too, like I say, if especially if you're going to like REST APIs, and yeah, they crash for some, or they take them offline, or whatever else. Yeah, I can give you some stuff. Yep.
So I get how the accept basically tells you what the error was, or can tell you what the
Yep.
error was. What's the point of the final statement?
So with this, right? So we can do try like response equals, and let's say I could say result equals response city, right? Mm-hmm. And then what I could do is I could say except. So if it's an except, I could say under an except result equals service unavailable. Mm-hmm. And then what I could do is for the finally, I could then print result to the final output. So let's say I'm printing to a web page. Mm-hmm. So I could then either, let's say it's weather. So therefore I could print out what the weather result is to the web page, or I could print out result, or I could print out the service is down. Okay. So that's where like the finally could be there. Like, and again, you don't. The only thing you have to put in a try except, you try and except are the only things you have to put in there. The rest are additionals based off of what you need. Questions? Yep.
Exception as is that just the syntax to get the error indication variable?
Yeah, so you don't need, so this doesn't have to be there. That's just a way to get the error. So yeah, except, exception, as, all of that has to be the same. And then the as E, that's just kind of like the standard. Everybody just uses E for the error. But you could put Bob in there. Yeah, it's just a variable name and then deal with it. Yeah.
Is E a string variable?
What's that?
Would E be a string variable?
Yeah, it will be a string variable. Yep. Yeah, because yeah, like when you printed this out, see how it's this whole mess that comes out?
I just think if you want to get fancy, you parse the string for variable types.
Yeah. I think it's always a string variable. Again, might be something to test, but yeah. Okay, so try accepts. Yep, Steve.
Is there, I've seen people be fancy and they'll go with accept expression as, and they know what E is. Is there any way to, the IDE with VS Code to like poke a request, you know, what sort of errors are from that? Like sometimes you'll see accept exception as IO error when you're writing to a function.
Oh, yeah.
I've never really known what exceptions would be from, and I wasn't really sure. This seems really easy, and that's what I don't really do. But
Yeah, so, okay, yeah, again, introduction to Python and AI, to be clear. Again, as I keep trying to explain, people were acting like how they can do like multiple things on different processors on a Raspberry Pi, and like it's a potato, it's a Raspberry Pi. So yeah, so within the try except statements with exceptions, there can be different types of exceptions. Again, that's its own mess to deal with that. Yeah. So you can. Yep. Okay. Any question there? No. Cool. Okay. Let's get to functions. So this is where you start getting into some more interesting programming stuff. What's the name of this function? Okay. So one of the big things that you want when you start programming in the real world is reusability. Again, how you can tell the noobs from the old timers is noobs say, I would never copy paste. And the old timers like, I copy and paste every day. I copy paste and tweak a couple of things. So yeah, again, that's one of the weird things, especially with new people, especially with new young people. It's hilarious because yeah, you get this whole like, they really want to reinvent wheels. They believe they will build a better wheel. And they're not going to, but everybody thinks they're going to. So the big thing with programming is we always want to create things that are as reusable as possible, especially when you start getting into longer programs, when you start talking about 200,000, 300,000 line programs. Instead of simply writing the same line of code multiple times or whatever else, you just want to write that line of code once and then be able to reuse it within the program itself. The other nice thing is when you start doing functions, especially as it starts to get longer, you can do this, I think it's called folding or collapsing. So I can do this. So imagine this function was like 30 lines, and I trust that the function works. I just want to get it out of my view. I can actually just click on that and it goes away. So anyways, basically we're taking a look at a function. When you're dealing with the Python world, so this is different with all languages. Python, this is how you do it. You do define, so def space, and so this is a keyword to say I'm defining a function. You're then going to create a function name, and then basically within here, you're going to set a variable name. Now the important thing to understand when you set this variable name, and that this variable name is positional. It's not based off of the variable that comes to it, right? So hello, whatever comes into index 0, we are going to call variable name. We're going to call it a name. Then we simply say print f string hello, whatever that name is. Down here, so we have to create the function first. So different programming languages work differently. Some programming languages dump everything into memory before anything actually runs, and so it can interact with anything. In Python, everything has to be inline, so you have to declare the function before you call the function. If you put the function underneath, it's going to fail out because it hasn't been declared first. One of those things. Anyways, so we declare the function up here. Here, I'm going to do person equals Bob. So not name, so I'm going to call him person equals Bob. And then I'm going to call the function hello, and then I'm going to put in that person variable. That's going to go up, and that's going to give me Bob. So when I run this, it's going to say hello, Bob. Woo, fancy. right? So that's the basic idea with a very simple function. So this does not have a return yet. That's not multiple variables or anything else. That is just a very basic function. So again, imagine if we're sending out email blasts or text message blasts. Imagine if I have a list of email addresses or phone numbers. I could just simply go through and I could say, for this one, do this, for this one, for the blah, 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 right? Anyways, any questions there? Cool. Okay, then we go to function multiple. Okay, so what's going to happen here is we're actually going to send multiple variables to the to our function. So again, still not a return, right? So here at index 0 is going to be phrase, at index 1 is going to be name. So we're going to print f string, phrase, and name. So hello, goodbye, whatever, and whatever the name is. We're going to set the variable name to be greeting. So greeting equals howdy, and person equals Bob. We're then going to say hello, greeting. So at index 0 is going to be greeting. At index 1 is going to be person. So greeting goes to phrase, person goes to name. So it'll be howdy, Bob. Does that make sense? So again, that's one of the things to get, like, again, words versus indexes. This is where people can get very confused, is with this, once you're in the function, you're dealing with the variable name that you set here. But when we're going from the call to the function, you're dealing with the index. Did I see somebody's hand? No. All right. So we go this, and we print, and again, howdy Bob. Ooh, right? So I said, hello. Right? You can do that. Hello. But the other thing too is, again, with that whole so if I do name first, phrase second, now it says Bob, hello. See, because it's the index. It's not the actual name itself. All right, get some nods. Good, good. Okay, now the next one that becomes important is where we actually start doing a return, right? So imagine with these REST API calls or these other things that we've done, imagine putting that into a function and then returning only the values that you actually care about, right? So that's where you get to function returns. All right. So basically what we're doing here, same thing that we saw before, right? We have the hello function, phrase, and name. So howdy and Bob. But now what we're doing is instead of printing this out, we're going to say response equals whatever we've created. And now we're going to return the response. So now the print is not within the function itself. We're returning the response. And so what we do down here is we say, so this response is different than this response. So out here, response equals function call greeting person, and then we're going to print the response. So this is what we're talking about. We're talking about returns. And so again, you still get howdy Bob, but now you're getting howdy Bob down here instead of howdy Bob up here. So we do return response. So you can call this variable name whatever you want. So you could say, again, you do response, just so you see that these are two different things, right? And so as long as you return, it's going to still keep returning that. All right. Yep.
That's a curious question. So typically when you do API calls, would it typically be done within a function and then you basically use it to return just a small fragment of what you're looking for?
Yeah.
Okay.
Yeah, because that's, again, and that's where I talk about with Silicon Dojo classes, like, yeah, do not put this code into production. So like, again, if you're doing a REST API call in the real world, you would create a function for that REST API call, and then within that function, you would have multiple try except statements. So where here, when we do a REST API call, it's like 4 lines of code, which again, if everything works, is fine. One of the reasons code bases get so big is, again, for validation, standardization, error, fail out, and that type of thing. So basically, you would take 3 or 4 lines of code, and you would literally turn them into 30 lines of code, basically to test so that there's not problems, right? If this works, if it doesn't work, what to do in this situation, and that's when it gets to be that bloated mess. Yep. All right. Let's see here. Then we get to the return multiple. And again, all we're dealing with is indexes again. So what we have here is we have a person's name. So person equals Bob. Response equals hello, so the hello function that we created, person. Now what we're going to be doing up here, and again, think about this if we wanted to deal with multiple returns. So we want to send some values up to a function, we want to get multiple values back and then be able to interact with those values. So I'm going to say welcome equals hello name, leave equals goodbye name, and future come again name. Right? So I want those 3 responses to come back, so maybe that's in my code. So all I'm going to do here is I'm going to do return. So I'll return welcome, comma, so this will be index 0, return leave, index 1, return future, index 2. So the response that's going to come back, welcome will be at 0, leave will be at 1, future will be at 2. So we're going to print out the response, and basically that's what you're going to see. And then if you want one of these individuals, if you want welcome, you do response 0. If you want leave, response 1. If you want future, you do response 2. All right, so if we do this, see this is where we come back. So I guess this is a set actually. So you get back, come back, and this is a set. So index 0, 1, and 2. And then we get hello Bob, goodbye Bob, come again Bob. All right. And you might do that kind of thing. Again, once you start thinking about complicated systems, so like once you start dealing with web applications, so Python is what's called a back-end programming language. So Python, PHP, those types of things are back-end. So those run on the server. And then you have a front-end language such as JavaScript. So JavaScript runs on the client computer itself. So you never want to send sensitive information to JavaScript, right? But if it's running on the client computer, it means all the resource consumption is being done on the client computer, so it takes resource consumption off your back-end server. So for a lot of things, let's say your JavaScript code has a lot of different outputs it can provide. It is easier on the system to basically be able to send all of those outputs to JavaScript, and then as the user is using JavaScript, those just come from the local text file instead of having to go all the way back to the server and come back to them. So like that's one of the reasons why you might have something as simple as this, is you send 20 different status types to JavaScript, and then JavaScript, just as they're using the script, picks the status that they want to use. Something to think about. So anyways, that is the concept between multiple returns. Is everybody awake? Or they're like, okay. Cool. Then we're gonna get to classes. I don't know. We're gonna like skip over. We're gonna say that classes exist. Oh, how to explain classes. Ugh. What do we got here? I got multiple. So classes pi and classes variable. Okay. So when you're dealing with classes, classes become their own mess. So we are going to glance over classes just so you understand that they exist, and then you can learn about them a little bit more later. So basically what classes allow you to do is classes allow you to put a lot of different things into one object. So whenever I talk about object in the Python world, everything in Python is considered an object. It's just weird word choice. Different programming languages consider objects differently. Everything in Python is an object. A variable is an object, a function is an object, a class is an object. It's all an object. Anyways, so the cool part about classes is you can put multiple things into one object. And so again, the idea here is readability. Remember, when you're writing code, it's not whether you can read the code, it's 2 years from now when somebody gets this crap dumped on them, are they going to be able to read your code? And so that's one of the nice things with classes is, so we talked about creating these functions before. So what if you can create a class that is going to have all of the functions that's required in order to do a specific type of task? So with Silicon Dojo, you'll see this with some of the code that I write. When we start interacting with databases, I will create a database class, and in the database class will be to create the database, to insert into the database, to select out of the database. And so anytime I'm interacting with the database, I always go back to that one class, and all those functions are there. So that's a value of classes. Right? So basically here, I just have a very simple class. So within classes, you can have variable values. So alert equals hello world. You can also have functions. So we're defining a function of hello, and we're defining a function of bye, and we're sending the variables into it. So hello, whatever the name is, bye, whatever the name is. So all I'm doing here is we do person equals Bob, then message.hello. So class, oops, that's not going to work. Class of message. So class of message dot hello. So the message class, the hello function, person Bob, right? So it should print out hello Bob. And then down here, it's going to print message dot alert. And so that's what the variable value is going to be. This is the one time when we talk about naming conventions for variables. I do not understand why. I actually Google searched this before because I was like, oh yeah, why is this? For whatever reason, when you're dealing with classes, you do camel case. Why? I don't know. Ask ChatGPT. So everything else is snake case in the Python world except for classes. Classes are camel case. And so we run this. And so there we go. So we get hello Bob, right? So here, person equals Bob. So the message class, hello function, person's name Bob, it comes up to the message class, hello function, and so it prints out hello Bob. Pretty simple, right? And then alert equals hello world. So we simply print message dot alert. So the message class, the alert variable value, and it prints that out there. They should be. They should be. That's why I do believe so. Yep, there you go. Air it out. Yep. Yeah, that's where. Yeah. Yep. So, yep. Okay. Okay. Any questions on that type of class? Okay. The other type of class to be dealing with is when you're dealing with variables. So one of the big things is, again, when you're writing code, you want to spend a lot of time now to try to cover all problems in the future, right? Don't write code quickly to deploy it just to run in that 0.0001 edge case, that's going to happen every 5 years and destroy your system, right? So one of the interesting things with classes is basically you can do this to essentially define the data that should come in for a variable. So let's say I'm taking information about students coming into my class. And so I know I always want a name. Let's just say I want an age, I want a shirt size, I want like a zip code or whatever else. And I want to make sure I always collect that information. One of the things that I can do is I can create a class for something like person or student. And in this, we're going to define an initialization function. So self equals, kind of like the function itself. Then we do name, age, and size. So self.name equals name, self.age equals age, self.size equals size. And basically what we do here, so we say student. So I'm going to create a new student is going to equal person Bob. So person is going to be self. So the instance is going to be self. And then the first index is going to be Bob. The second index is going to be age. The third index is going to be size. I can print all of this out. I can print out all the variables. And then what I can do with student, I can do student.name, right? So self.name, so student.name is going to be Bob. I do student.age is going to be 11. I do student.size is going to be large. So basically, this is a way that we can kind of define how information about something should look so that we can get that information into our system. If we do this, we print this out. When I print out just student, right? So I print student, you're going to see I get this object value back. So this doesn't actually show me what the hell's in that object, right? So that's why I do print vars for student. And now what this is going to do is it's going to give me name of Bob, age of 11, size of large. And then when I go down here to student.name, student.age, and student.size, you give me Bob, 11, large. So again, imagine I'm dumping all this stuff into the database. So I want to collect all this information about the student, and then I want to do a SQL statement into my database. That way I can do student.name, student.age, student.size, and all just gets dumped in relatively seamlessly. Again, the other thing to be thinking about too is remember when somebody is going to be looking at your code in the future, it makes it easier, again, for them to understand. So when they see the student is being created, one of the questions that's going to come up is like, yeah, but what are they actually what data are they actually trying to get here? So they can go up to this person class and then get a better idea of what that data is supposed to look like. Yeah.
So how are you able to reference, variables from within the function?
Okay, so when I create student, so student is going to be self, right? So in this initialization, so student is going to be self, and so when I come in, so then the name that comes in, so self.name, so student.name is going to equal name for Bob. Student.age is going to equal the age that comes in, and student.size is going to be the size.
Yeah, I get that. I was just wondering, like, because so when I was in college, I did C++. I didn't think you could reference variables from within the function. Does that make any sense? But I see you can. I just didn't know that you could do that.
With
Like,
it,
I thought that the variable like self.size
yeah.
or dot size, whatever, that would have been isolated to the function itself, and that it wouldn't have been able to be.
Well, no, because student, see, I'm creating a variable student that is going to equal the person class. So it's going to be student.name. So self. I guess that's here, but it's student.name, student.age, and student.size will now be student.
Okay.
Does that make sense?
Mm-hmm.
Again, I've got to get better at explaining classes, to be honest with you, but yeah.
When you use the init, because on this class you say you use an init string to initialize your thing, whereas other classes do not.
Yeah.
So why?
Because here I'm creating this variable name for something like student.
So you're replacing the.
Yeah. So like you might use something like class like this. Let's say you're connecting to a server. So you need the host name or IP address for the server. You need a username. You need a password for the server. Maybe you need a port for the server. So what I could do is I could basically, like imagine, imagine let's say we have 5 different SQL database servers. So they all require the same information, the same type of information, but different. Right? So I could do a class of SQL login of host, let's say host name, account name, password, and port. And then I could do like the, caching server equals SQL login, blah. And then going forward, all I do is have to do caching server dot host equals blah, caching server dot. You kind of get what I'm saying? Yep, so you can, because again, that's the whole reusability concept here. Yeah.
I'm just about to ask, that's, when you do the event, that makes it reusable, right? Just it's like guidelines for a class to be reused. You can just plug information into it as necessary.
Well, yeah, the initiate, basically what this is doing is this is assigning these values to the variable that you're creating at the .name, .age, .size. Yeah.
So the first one, you can't change anything, right? Like, the first class we did, that was just set.
Yeah, the first, what was it? That, yeah, that's just kind of set. Again, you're just creating this to be able to reusability. Yep.
Yeah, that's what I was alluding to. Like basically, in that first class you did, you wouldn't be able to use the same variables outside of that class, or not class, but yeah, class. You won't be able to use those variables outside of that. But in this one, I guess with the init.
Well, yeah, because it's no longer outside. See, like, so I can't do print self.name, right? I don't think that'll work. So this is inside this function. So this should fail. All right, it's gonna fail. Yeah, see, it's gonna fail, right? Because I'm trying to call this from outside the function. So what happens here is, again, and that's where, so there's something called local variables and global variables we're not going to get into today. Python really does not want you to use global variables ever, so you're always passing information. And see, that's what you're doing here, is so you can't access self.name outside of this function. You can assign the value of self.name to this variable, and now you can access that variable value. Because this is inside the function, this is outside the function. Yeah.
So is that why in line 10 we have print vars, comes back with a valid response?
Yeah, when you're printing var, so that's what's telling me, right? So student equals this class, and so I'm printing out all of the information that's coming from that class.
And line 9 failed, print student.
Well, no, it didn't fail. No, it did not fail. It's just showing you that that's an object. Like, so that's gonna be one of the problems you get to. Like, a lot of times you're like, what the hell data am I looking at? And so it'll do like print and whatever, and you'll just get something like this. And no, it's telling you what it is. It's an object. It's just not giving you what you want, and that's where you got to figure it out. Yeah.
Is the, when you init, the first, the index 0, is self a keyword, or is this just whatever you want to call it?
So self is this.
Right, but the second self, you also can use self, or can you make whatever you want?
Oh.
Just ask me.
Oh, God help you. I mean, I guess you can make whatever. Again, it's an index. The importance here is just the index. So, yeah, you can change that. Like, everybody will hate you forever, though. Like, I don't imagine a reason why you would. But that's where it's like, I got to think about it. Like, no, you can. Like, you can, but.
So the definition is just based on the index value, not what's, okay.
Yeah, these are index. What gets passed up is index value. But yeah, just do self or people will hate you.
Literally just change that to Apple and probably function.
Yeah, I mean, I should. I mean, that's Apple. I think, right? That'd help us. I do believe. We'll find out. Apple. Yep, you can change it to Apple, but you will be hated. You'll be fired and hated and pilloried and yeah. Well, because the thing, like, you also have to remember too, is like when somebody comes behind you, they're going to assume you did something for a reason. And so they're going to spend 5 days trying to figure out why you called that Apple. They're going to be like, there was a reason he called it Apple.
That's what comments are for.
Yeah. There you go.
So you're saying before you quit.
Mm.
Line 372.
Yep. Well, again, like one of my viewers I was talking to, he literally had a buddy of his. So we talk about arrays. So you can have multi-layer arrays. So there's one-layer array and two-layer arrays. When we talk about AI and LLMs and neural networking, there's something called tensors, which are called three-dimensional arrays. This guy was such a he was impressively a jackass. What he did was he wrote all of this Python code where everything was contained in 9-layer arrays. Because the idea is most human brains, and like technically you understand it. Like, I mean, 9-layer array, like you're like, oh, that should be simple. Like there's no reason that should be complicated, but for some reason the human brain just goes, ugh. Like once you get past 3 layers in an array, the human brain just futzes out. And so it was literally his job safety. Was like nobody could like just mentally nobody could understand his code. So yeah, you got to worry about that kind of stuff. Yeah, job security. Yep. Okay, so we have 2 little more lessons, then we get to the labs, and you guys can go out for lunch and do whatever you want. So files. Yep. Okay, so interacting with files. This is all pretty simple. So there are multiple ways to interact with files. In Silicon Dojo, this is the way you should interact with files. Generally, this is the only way you should interact with files. There is a different way to deal with files. You can deal with a file where you open the file, you do stuff to the file, and then you close the file. The problem is if you forget to close the file is open, and everything else breaks. Because basically what happens with these programs, this code, is when you're using something, when you're using a resource, that resource gives you access to it, and nobody else can get access to it until you release it. So if you forget to release for some reason, hell ensues. The nice thing when you use this with open function, when you're interacting with a file, is it will automatically close the file when it gets done with the code block. So you can do all kinds of things with a file inside the code block, and once that code block is finished, it auto-closes the file for you. You don't have to worry about it. So if you see the other way of opening and dealing with files, just basically don't deal with it. Anyways, so when you do this, you can do so with the open function, then you put in the file name, whatever you want the file name to be, so file.txt. Then you have the W. So W is the mode. W is the mode. So with W, that is overwrite. So it will either create a new file or it will erase the old file and write everything over that. So whether or not you like that, that depends on what you're trying to do. You have append, you have A you can put there. So what A is it appends to the end of the file. So if you're doing like some kind of little record store, you want to keep adding records, you do an append. Or you can do R, which is read. So if you want to make sure your user does not screw with your file, only reads the file, you can open it as R. You then say A as, and then you put whatever variable name here. So we're just going to call it file to make our life easier, right? So this could be Bob, this could be Apple, whatever. Then you do colon. Then what you can do here is you can do file.write, and then you write in whatever you want to write into the file. So here we're putting in hello world, as we always do, but you could put in variable values or whatever else. Again, this could be a CSV value that goes in. It's going to write to the file, and then it's going to auto close. If you want to read from a file, basically you can do with open, same thing. We're just going to use the R mode as file. And then we simply say text, or whatever variable name we want, equals file.read. So you can either do read, I guess is the method. Is it a method? Probably a method. You can either do the .read, and that reads everything into text. So it's just going to be a big string. Or you can do read lines, and that will read every line into the value in a list, whichever one you want to use. Right? And then we're going to simply print out text here to show you how this works. Right? So we're going to write, let's see, file.txt. So I'm going to erase file.txt here. I'm going to delete. So that goes away. I will run this. Now we see that file.txt got created, called hello world, and then we print out hello world here. Right? So basically we wrote hello world to file.txt, and then we opened file.txt and read hello world and printed it out on the screen. Pretty simple. Any questions there? Cool. Okay, then let's take a look at the basic formatting. File.format. So one of the things you have to be thinking about, again, is the user interface, how people are going to be interacting with the data that you're printing. So most of the time, you're going to be printing to things like HTML dashboards. So when you're dealing with HTML, you're dealing with HTML tags, H1, P, pre, H2, whatever else. Sometimes, though, you're going to be printing just to a command line screen, or you're going to be printing to a text document. And so there's ASCII encoding that you can use. It's all pretty simple. Basically here, what we're doing is going to be ugly as hell. So you say hello world /n. So wherever you have a /n, that's going to be a next line. That's going to go to the next line. And then you have here /t. And so wherever you have a /t, that's going to be a tab. Right? So this is how you get to, like when you're using a command line tool and you get a nicely formatted spreadsheet looking thing, basically they're using /n's and /t's to give you that. So all we're doing is basically the exact same thing we did the last time, and we're putting some of this ugly formatting in there. And there we go. So hello world, we go to the next line. This is using ASCII formatting. /n gives you a new line. T space gives space, U tab spaces. Just kind of gives you an idea of what's going on there. And this is one thing to be thinking about too, especially when you create HTML documents that gets really interesting. Again, when we start talking about how do we go from 5 lines of code to 500 lines of code. So remember with HTML, you are, when it comes out in the web browser, all you need is the H1 tags and that kind of thing. But if you go to take a look at source, that's in text. That's in ASCII. So if you're a good programmer, you should be formatting your text both for HTML and for people to be able to read it in ASCII. And that's where you get into to start bloating up your code a lot. So anyways, that's a basic idea with files and formatting. Any questions? No? Cool. Okay, final thing is operating system, and then we get to some labs and lunchtime and coffee, so some people can wake up. Okay, so let's take a look at, what did I call this? Command.py. That's one thing too to think about is whenever you're naming your scripts, make sure they don't have the same name as things like modules. So if I call this os.py, then I'd start getting some weird conflicts and everything would go to hell. So that's why I call this command.py. Anyways, so one of the cool things with Python, one of the things that makes it great is you can interact with the underlying operating system. So again, one of the big things is we do not reinvent the wheel. 18-year-olds reinvent the wheel and they fail. We don't. So what's great is what can make our system so powerful is if you look at Linux, right? Linux has 40 years of development already done on that operating system. And the cool part about Linux is almost all of it's command line. So one of the big problems you deal with in the programming in the technical world is how do I get text, right? And so whether it's voice, whether it's a visual input, or whether it's a graphical user interface, right? I can't use that. it's very hard for me to use that from a coding perspective. As soon as I can turn it into text, life gets a lot easier. So one of the issues is in the Windows world, you have so many graphical user interface tools. They're great, but you can't really use them outside of that graphical environment. What's great in the Linux world is they have thousands and thousands and thousands of command line tools that as long as you know the command and the arguments and the options, you can just use those command line tools, get the response back, and then do something based off of that response. So when you're using the operating system in Python, there's two modules. The first module is called OS, and that's what I'm showing you today. Just to be clear, in the real production world, you should use a module called subprocess, but it's more difficult and complicated, so we're not dealing with it today. But it's safer. Use subprocess in the real world. We're using OS today. So what we're doing here is very simple. So command equals, and this, you're going to need to use this on, for anybody on Linux or Mac. Ping space C1 is going to be the command. So ping, just ping a host. We're going to do a count of 1. So in the Linux world or the Mac world, when you run the ping command, it runs until you manually stop it. So if you just do ping and walk away, your script is just not going to work out well. So you got to give it a count of 1. If you're in the Windows world, oddly enough, to give a count, you have to give it as like an administrator level. So anyways, you can just do ping and leave out the count. Anyways, that's one of the things you have to be thinking about with the different operating systems. So what we're going to do here is we're going to have a while true loop so we can ping different hosts. Host equals input, host to ping. So you can ping CNN.com or 127.0.0.1, whatever your host is. So a fully qualified domain name, again, is CNN.com, Fox.com, TacoBell.com, Google.com. An IP address, 127.0.0.1. If you don't know what an IP address is, leave it at TacoBell.com. That'll be a different class. Anyways, so response equals ping host, right? So we create this ping function, define ping host. We do response equals os.popen. So what the popen function does in the OS module is it sends a command to the operating system, and the return that comes back gets assigned to as a variable value. So you can do os.system. So the system function sends a command to the operating system. That's done. You don't get a return back. This actually gives you a return back. So what we do here is we say fstring command, so whatever the command is, space host, so whatever the host is, dot read. So before we did JSON with things, so this is read, so this is just going to give us a text response back. And then we're going to return that response, and then we're simply going to print that response out, right? So when we do this, I'm going to say ping, I don't know, I can't do Taco Bell. I screwed that up on my system. That's when you play with host file and you don't want to fix your host file. I don't know, Walmart.com. Oops. The hell? I don't know. Ping CNN.com. Oh, now you're giving me problems. Why are you giving me problems? Host to ping, CNN usage, ping. This was working. Wait a minute. See it? Oh, nah. No, God knows. Anyways, again, that's technology too. Why is it working now? Who knows? So anyways, host to ping, CNN.com, and so I get this nice little response back, 1 packet. Right, I'm going to do Fox.com. And now I get this response back. And so this is a really cool thing. Again, one of the things we're going to do is an up-down dashboard. So that means from my script, I can now ping, let's say, all of the servers that the employees in my company are using and continuously monitor to see if there's a problem. So as soon as there's a problem, it can flash red. I can start fixing that before we start getting work orders into our call center, to our help desk. So that's with the OS. And yeah. That's a very simple lesson on how the operating system thing works. Any questions with that? Okay. Then we will show you the couple of labs, and then you will go out to lunch, and then some of you will come back, I'm sure. A couple will come back. Anyways. Yep. Okay, so we're going to go to up, down. Up, down. All right. So what this is going to do is this is going to give us a dynamic dashboard. So we're going to create a while true loop. And what we're going to do is we are going to output to an HTML file. That HTML file is going to update every 5 seconds. And so what's going to happen is we're going to ping all of these hosts. We're going to get the response back. And then we're going to write to the HTML file. The HTML file will auto update. So if we do this, just so you see this. We don't find her. So what we're doing here. 1 Mississippi, 2 Mississippi, 3 Mississippi, there goes, updates. 1 Mississippi, 2 Mississippi, 3 Mississippi, updates. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, updates, right? So basically what I have here, as you can see, CNN.com, Fox.com, and TacoBell.com. We are getting these updates. And this is where it can show you problems. So again, if any of you folks know anything about IP addresses in TCP/IP version 4, you will see that TacoBell.com goes to 127.0.0.1 because I was screwing with my host file and I never got around to fixing it. So anyways, so this gives us a nice little dynamic board. And again, this starts to show you the value of things like Python, where you can build it. You can literally take this as it is, and you can start running it on your systems, again, to verify Salesforce or whoever you're using is up and running. So we take a look at this, wherever my code is. All right, so let's take a look at this. So we're going to import OS. So that's the OS function, so that allows us to ping. We're going to create a list of fully qualified domain names that we're going to ping. Again, CNN.com and Fox.com. We are balanced here. Both CNN and Fox come together. And then we use Taco Bell, really the metaphor for the modern world. Anyways, then we're going to do ping -C1. So if you're on the Windows world, just do ping. But if you're on a decent operating system, do ping C1 for the count of 1. Then we're going to come down here to a while true loop. So this is going to continuously be going. So page equals, we use these 3 quotation marks because we wanted to put this on multiple lines. This up here is called a meta tag. And so what we do is we auto refresh every 5 seconds. So this is a very simple way to create an auto refreshing HTML page. And then we say H1 up down dashboard. So this gives us a title for a little app. Then all we're going to do here, so this is page, so we're going to create the page here. Then for site in host, so that host list for each site, response equals os.popen, command site read. And then we're going to say page plus equals, right? That whole iteration thing we're going to add. So we're going to plus equals, we're going to add the pre tag and response. So pre in HTML leaves the formatting as it is. So it gives you decent formatting, so it's just not one big ass long line. Right? Anyways, then what's going to happen is, so we're going to go for each site. So we're going to create this for each site. We're going to add what the response is. And then finally, at the end, with open dashboard.htm, we're going to overwrite. So we want to erase everything that was there before as file. And then we're going to write to the file all the page values that we created. And that's what gives us our dashboard. Does that make sense? Cool. See, and the thing too, like if you followed along online when I've done things, like what you can do is you can start, when you start, where is this? Like once you start having this, if you understand how to start pulling information out, you can very easily start using things like CSS, cascading style sheets, to then format behind the text, right? So, so this is the latency here, right? So like, so CNN.com is 180, Fox is 149. These are high. Anyways, so let's say if CNN.com is like the latency is above 100 milliseconds, you might make the color behind it yellow. So if the latency is below 100 milliseconds, you can make the color behind it green. If it's above 100 but under 200, you can make it yellow. And if it's above 200, you can make it red. Right? That's where, again, you can start adding some functionality. There is some extra credit for you. Okay, then we have a joke. Woohoo! Have some fun here. So our joke lab on page 30. Let's take a look at this. Nope, not joke. Okay, so basically what this is going to be is this is going to be us using our REST API And hopefully this random joke is going to work properly. So this is a free REST API done by somebody probably on a Raspberry Pi. So we'll see if this goes well for you folks. If it fails, it's probably not your fault. Anyways, so what we're doing here is we're going to import requests, URL equals basically the joke REST API. We're going to get the value back as JSON. And then out on the command line screen, we're going to print the setup and the punchline. So this is kind of like troubleshooting just to prove it's working for us. And then what we're simply going to do is with open. All about ready to start with the afternoon? All right. Good deal. Oh, the one thing I realize as everybody starts to leave, if you don't know this exists, silicondojo.com. So this is our main web page, even though we use Meetup right now just to make life easier. This is the main web page. All of our upcoming events will be here. When you click on the RSVP, it'll dump you to the Meetup group, but just so you can see everything that's actually coming up. This will be important as we start doing events in other cities. So I live in Asheville. We're going to start doing classes in Asheville, and we'll also start doing full day classes in Asheville too. So if you want to come to those classes, you could see that they're here, and you're like, oh, it's Asheville, and you click through, and you sign up for that particular meetup. The in-person classes, again, we are recording this. God knows how this video is going to turn out. Most of these videos are pretty good, though. So whenever I do these classes, the videos are here. Plus, all the information is on GitHub. So if you just want to watch these at home, again, these classes are only about 2 hours. They shouldn't be too bad. Previously, I've done fireside chats. I will do more of these. So this is where I'm actually talking to like real people in the technology world. Again, like literally like David Cox, VP of AI models for IBM, had him on talking about artificial intelligence and that type of thing. So we do have these here if you're interested in those. And we do have the self-study program. So we have an introduction to programming class that has many people, introduction to Python. So some of this stuff, we are rushing through some of this stuff today. This is 49 modules, and so each module gets a little bit more specific about everything. Again, if you're dealing with Windows, dude, it's Windows. It's its own world. Anyways, we have SQL. So SQLite is a database system. We will do a full day class on that, and we'll do something called Bottle, which allows you to create web applications. So all of these classes are there. And also, you can tell what a good business person I am, because after half the class leaves, I remember to tell you folks, do remember this is all free to the end user. Oh, come on now, give me my donor box. This is all free to the end user. Basically, this is all crowdfunded. So for my viewers on YouTube and from people who have come to these classes before, you can go to DonorBox. You can throw some money in. Monthly is very nice, even $5 a month, and that's what helps pay for all this stuff. Because again, I am driving here, hotel room, paying for an office, all of that kind of thing. The idea with Silicon Dojo is to abstract out the financial component from the education component. It doesn't mean the financial component doesn't exist, though. So again, if you're willing to, that exists. And with that, we will get into the final bit of the class today. So we are only going to have a couple of actual lessons, and the rest of everything is going to be labs. So you're actually going to be building little AI projects, because again, that is the entire point of being here. I do really want to emphasize that for everybody, especially who wants to be in the technology world. It is all about building. As I used to tell my viewers, whether you're fixing your computer for your grandma or for a CEO, Windows is basically Windows. Again, coding is basically coding, creating function calls and all of that, whether you're doing it for yourself or whether you're doing it for an enterprise system. Of course, using hand grenades is about the same thing. So it's important to do some work. Okay, so let's talk about Ollama. So basically what Ollama is Ollama is an open source framework that allows you to run LLMs and other models on your local machine. So the cool part about this is everything is running locally. So you have a lot of different models out there. Again, there's LLMs, there's reasoning models, all of that kind of thing. Basically with this, you'll be able to run all of the text-based models, and what's actually pretty cool now is they do have vision models on here. Basically Lava is kind of the standard vision model a lot of people use. And so basically what this is you can use this to send or basically give the model an image and then be able to ask questions about that particular image, and it will give a response back. The Lava model works well. Again, if you've got an M2 Max system, it has a pretty good response time. If you use a Raspberry Pi 5, I will say Lava works on it. It just takes 5 minutes to give you a response. So, it is as it is. But anyways, basically that is what you've got when you come here to Ollama. So you come to Ollama.com. They have lots and lots and lots of different models here. So again, I like the Granite model now. We can see that they've got Granite. I want Granite 4. If you're searching for something, oops, I don't want Vision. There we go. So I want the Granite 4 model. I can click on the Granite 4 model, and this will give us many different options here. So basically, when you're looking at the models, you'll see different sizes. So with this, you'll see 350 million parameter, 1 billion, or 3 billion parameter. More or less, horseshoes and hand grenades, your system can run a model maybe about the size of the how many parameters it has, right? So basically, if you've got about 4 gigs of RAM on your system, you should be able to run a 3 billion parameter model with a relatively adequate response time. Again, the smaller the model, the better. So basically, the idea with these models is the smaller the model is, the less it knows, right? So, you know, who the king of France was in 1300, a 350 million parameter model probably doesn't know that, whereas like a 480 billion parameter model will. One of the important things to be thinking about when you start developing for artificial intelligence systems, though, is the whole question, and this is one of my frustrations in the AI world, is what the hell problem are you trying to solve? Am I really trying to build a system for my company that's going to say who the king of France was in 1300? Do I want to spend $40,000 per GPU so my employees can ask who the king of France was? No, right? And so that's one of the big things to be thinking about with these different models is what model actually solves the problem that you're trying to deal with. So one of the things, if you've been to any of my other classes, you know, with artificial intelligence, I really am interested in things like function calls. So essentially, you create a list of function calls. This could be agents or that type of thing. And then basically, in a natural language way, be able to communicate with your system and then basically have it fire off the function. If I say K-Aura S, will my AI be able to tell me what the current time is? Well, the interesting thing with that is I don't need 480 billion parameters. All I need is the system to understand I'm asking for the current time, to know what function will give the current time, and to return a function that's 3 lines of code. And so again, that's one of the things you really have to be thinking about these AI systems. If anybody here watches my YouTube channel, again, I recommend you don't, but if you do, you will hear me lose my mind about artificial intelligence, and it's not actually about artificial intelligence. It's about $1.3 trillion in CapEx expenses. That's what I don't get. LLMs are fantastic. Vision models are fantastic. This technology is fantastic. It's not $1.3 trillion of fantastic, though. That's the whole issue. And so that's the thing to be thinking about when you're going around and playing with these models. And so if you come here to Ollama, they've probably got about 1,000 models at this point. So go play, see what the hell works for you. Again, I like the IBM Granite models. And that's not just because I'm kissing up to IBM. Though apparently I have an IBM person that wants to talk to me. So maybe we'll get pizza in the future. Yay. Okay, so if you come here and you want to download, so the first thing you need to do, and you will need to do, we'll get to this once we start doing the labs. But anyways, you'll come to ollama.com, you'll click on download. If you are on Mac, you click on download. If you're on Windows, you click on download and you install. If you're on Linux, you get an SSH command, you get a curl command. So hopefully curl is installed on your system. If not, sudo apt install curl should be installed on your system. Basically what you'll do is you'll copy that. So if you can copy that, and then you can paste it if you're on Linux. And the one thing to make sure if you're on Linux and you do a copy and paste, a lot of times it'll give you additional crap in the front and the end. So you just got to delete that additional crap so the command will actually run. But anyways, so basically what you're going to do is you're going to install it. Once you've installed it, you can then go to your terminal or your command line. And then what you're going to do is you're going to pull a model. So since I have no idea the quality of your guys' systems, we're going to pull the Granite 4 1 billion parameter model. That should work on all your systems with a reasonable response time regardless of what you have. Again, just understand my 2012 MacBook Pros with 4 gigs of RAM and dual core processors, they can run the 350 million parameter. So a 1 billion parameter should work on any system after 2015. So anyways, all you're going to do is you're going to do a pull command. So it's Ollama, pull, and then Granite 4, and then make sure you put the 1 billion parameter model in there so you get the right model. If you don't put that, it'll pull down, I guess, the 3 billion parameter model. And then you're going to hit enter, and it's going to be pulling the manifest. Okay, so it is already installed for me, so it was that quick. For you folks, it'll download a file, and you can notice it's about 4 gigs in size, so it'll take however long that takes. right? Past that, then all you do is you do run, right? So you do Ollama run, ran it for 1B. It'll take a second to run. And this is where we have the Ollama shell. So this is how we prove to ourselves that at least Ollama is working on our system. It's, you know, it's not our Python code yet, it's Ollama. So I can say, hello, how can I assist you today? I can say, what is a woodchuck? There we go. And that's what's pretty cool. I mean, that's a billion parameter running on this thing. Oh, that's a recipe for lasagna. Yeah, there we go. Anyways, doesn't give me any additional information. So anyways, but that basically gives you the idea and it shows you that this is actually working. Once we start using, I'm still on that. Once we start using Python, the one big thing is that the Ollama service does have to be running on your system. If Ollama isn't running, it'll go to connect to Ollama and it'll fail out because it's not running. So Ollama basically configures itself to start on startup, whatever system you have, so you shouldn't run into this problem. The only way you'll run into that problem is if you're worried about security or whatever, and you quit Ollama, and then you go to use Ollama in Python, and then you'll have problems. So in today's class, it shouldn't be any big issue. That's about that on the introduction to Ollama. And this is really, again, this is basically an LLM in its most basic form. Again, you can use GPT OSS. So to get out of this, you do /exit. Always know how to get out. So if I do Ollama run GPT OSS, so this is OpenAI's open source model. Again, the same thing. I can say, who was king of France in, I don't know, 1305? And then it's thinking, because it's a thinking model, and then it spits all that out. Right? This is going to be one of the interesting things, too, to be thinking about, is again, safety in the AI world is very bizarre. I don't understand what's going on with safety. Like everybody's worried about, I don't know, chemical weapons and all that, and instead you get answers like, I can't tell you who the current president of Russia is. Like I've asked, like, who was the last czar of Russia under the Granite model? And it's like, I don't want to get political. I'm like, dude, come on now. So you do get into some weird responses. Is that a question or just a?
Yeah,
Yep.
you can jailbreak them, right?
What's that?
You can jailbreak the AIs.
You can jailbreak. Well, that'll be for somebody else. I'm just showing you folks this kind of stuff. Yeah. So anyways, again, depending on your system and the responses, depends on what you're going to use. The other thing that I would have you think about from a real world perspective, so one of the big issues we have right now in this whole AI arms race is this whole idea that we all need to spend gazillions of dollars on AI architecture. One of the things I really want you to be thinking about for your systems, when you deploy this in the real world, real architecture question, is what does your response time actually need to be? Right? When I talk about a 5-minute response time for a Lava on a Raspberry Pi 5, that seems like a joke. But something to think about, not that I would actually run this on a Raspberry Pi 5, but something to think about here, is that means it can process 12 images an hour. That means it can process approximately 300 images per day on a Raspberry Pi 5. So if you have a marketing team and they're going out and they're taking 10, 20, 100 pictures a day, you could have a Raspberry Pi just processing that stuff in the background and auto-updating stuff, and you're not going to run into any problems, right? Is it going to be as fast as a $40,000 GPU? No, but also is a $40,000 GPU worth it to you? As long as you get an update in a reasonable amount of time for your business, a Raspberry Pi 5 might actually be fine for you. And that's one of the things, again, the whole argument about do we really need $1.3 trillion in CapEx expenses, is imagine if your system, like for these AI services, when it comes to your email, when it comes to your documents, when it comes to your images, imagine when the screensaver comes up, it just starts chugging along and processing. So not even hitting your performance while you're using it is just kind of a background service. What you find out is will be fine for most people at the end of the day. And so again, it's one of those things that you have to think about for your particular systems. Okay, so then we get to actually running Ollama in Python. So let me go here. Ollama basic. So this is the basics. This is all we're really doing. We're building. And so again, this is one of the things you have to understand about the technology world and the coding world, is there's this whole idea that what we do is very difficult. And the reality is we learn a lot of small things and we duct tape a lot of small things together. So everything that you've learned today, now we're going to simply add, I don't know, what is this? 11 lines of AI code, and now we're going to have artificial intelligence, right? Anyways, so you're going to install as we have on page 34. So we're on page 34. Oops. Where's my thing? Okay, we're on page 34. So the first thing is we're now going to have to install the Ollama module. So before we installed Ollama as a service on the machine itself, now within Python we need to install a module to be able to communicate with that particular service. So it's just the Python 3 m install the module. Once you've done that, again, as I say, this is basically 11 lines of code, and this is essentially the copy and paste that you get from Ollama. So up here, I don't know why they do this. I've left this way just because, again, it's the copy paste. Really, what this should be, just so we're clear. Oh, control. Yeah, one of those days. What this should be, Command X, Control V. Remember how I told you you could import multiple functions at the same time? This is how it should be by standards. I don't know why, but when you look at the Ollama documentation, they do it the other way. Anyways, so from Ollama, we're going to import chat, and we're going to import chat response. We're going to do this whole response colon thing here. So basically, this is kind of weird. So this basically means response equals, and we'll keep the data type of whatever comes back here. So when we see like response, or you see a variable name colon, it's basically the same as equal. You're creating a variable. Then we're going to do chat response equals, so chat response, and we're going to do chat for the function. So model equals, and this is where you plug in whatever model you're going to use. Doesn't matter, GPT-OSS, Granite 4.1b, whatever. Then we're going to have messages. Here we're going to have role as user. At this point, you don't screw with roles. So if you go back about 3 years when you were dealing with AI, there were multiple roles. There was a system role, there was assistant role, and there was a user role. And those all made a bit of difference. At this point, that's all kind of gone by the wayside. So you just leave role as user. And then the content is basically whatever your query is. So why is the sky blue? Right? And then we do print response. And this, again, this is basically a layered collection is how you would look at it. So response, message, content, that will print out the response for you. So if I say, why is the sky blue? And I run this thing. Come on now. There we go. And it will give me way too much. What you'll notice with these LLMs, and this is one of the reasons why prompt injection is important, to tell them to be shorter, is they will just keep going. So anyways, the sky appears blue due to a phenomenon called Rayleigh scattering. Here's how it works. Sunlight contains blah, 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 blah. So anyways, that's your response there. So basically what you can do is this is how you print out just the response. Now, if you want to take a look at it, again, as I say, it's kind of like this layered collections. If we print the response, the complete response back, this is what we'll get here. So, okay, so this is where we see model equals Granite 4.1b. So it tells me the model that was used. It says when it was created. It says the total duration. It shows you evaluation tokens. It shows you some other stuff. And then we have message equals message, and then we have content here. So that's where when we're taking a look at it, we say response, message, content. So it's all of this is a response. Then we go to message, and then we go to content. Now, for some reason, everybody has decided that, anyways, everybody decided that the class way is the way to start giving the responses back. So if you actually look at the response type that's coming back, it's now a class. So everybody used to do basically this in order to parse the response. Now everybody's doing this. And so this is kind of like that class like I showed you before. So response, message, content, and that will give you the response that you're looking for. So anyways, and you'll notice that with OpenAI. So we'll have another class on the OpenAI API, and they used to format everything like this. And then I don't know, about a year ago, they decided to start formatting everything like this. This is one of the problems that you're going to deal with in the artificial intelligence world. Is there's a fundamental misunderstanding right now with AI architecture. There's a concept that AI architecture is what's called mature. So mature architecture our mature systems are systems that we know how to build. So if you go out to build a web application, everybody's going to build the web application exactly the same way. Or maybe there's about 10 different ways you're going to build a web application, but we all know how we're going to build it. One of the things to understand with artificial intelligence is all of this stuff is relatively new, so things change at an idiotic speed, right? So I have actually been doing in-person classes in Asheville since, 2002, I guess. And whenever I teach an artificial intelligence class, one of the problems is I'll create this class, I'll make sure it works, I teach the class, it's great. I put it up on the shelf, I come back 3 months later, take it off the shelf, dust it off, basically because I'm going to teach the class again. And what should happen is I just dust it off, verify everything works, and teach it. I dust it off, run the code, everything fails, and then I'm spending another day literally rebuilding the crap that 3 months ago worked perfectly fine. So anyways, that is going to be one of the concerns, and that's also something that you need to be worried about with AI systems if they're going into production. Because one of the issues we run into is if you build a system properly, or if your company doesn't have enough resources, you're going to build a system, you're going to deploy it, and it's not going to get touched for a year. That's just how it is, right? As long as it doesn't break, as long as it doesn't blow up, it's not going to get touched for a year. One of the issues you might run into based off of the resources and the systems you use to build a system is when somebody comes back in a year, it might be a complete disaster to try to make everything function properly again, right? They come back to the system and they go, oh, look, people haven't done preventive maintenance. People haven't updated this thing. They update it because they're just being good little boys or girls, and all of a sudden everything breaks because the old code does not work with the updated software. So be very careful. Again, if you're dealing with these AI systems, I would really say make sure to feed and water them at least once a month just to verify you actually understand how the damn things work. Because again, it's amazing, like doing these AI classes is a pain because just things change every few months. It's just ridiculous. Okay, so that is the basics of that. Any questions there?
What is the point of Ollama? Why would we want to put this on our computers or have it locally as opposed to just using like, what's the company? Another one that's on
OpenAI? It's really up to you. So since this is local, none of your data goes away. Since this is running on your system, there's no cost for API calls. So if I do a while true loop on this, it might burn out your GPU, but it's not going to cost you any money. Again, being able to play around with it, you don't have to worry about API keys. So if you use OpenAI, you are going to have those API keys. Again, there's no security issue with that type of deal. So again, it's kind of one of those architecture things. You've just got to decide what's valuable to you. Yeah.
Can we build upon the data sets that's already there? Is
So,
there a way to do that, like to add to it? Like if our data doesn't leak, can we start to accumulate it to make it smarter?
Well, it depends on what you're doing. So you can train your own models and you can run your own trained model on here, but I mean that's its own couple-day class in order to do that. Or again, if you want to use RAG, so we'll have a class on RAG in future. So what RAG is, it's called retrieval augmented generation. So you have your own database system of information, and you can create a system for your AI where when somebody asks a query, it will try to find chunks of data in your database that might be able to answer the question. And so that's where you get to what's called context engineering. So your query plus all this information from the RAG will then go into the system and it might give you a response. And again, that's one of my arguments with this whole what makes better artificial intelligence. I highly question if we really need bigger and better foundation models. Again, in 2026, do we really need better foundation models, or do we need better RAG systems? I would argue we need better RAG systems. So that's, okay, any other questions? No? Cool. Okay, let's go to page 35. So, oops. Oh yeah, all right. I guess we're gonna get into labs. Okay, so I'm gonna show you how to do these labs, and then you are going to be tippy-tap typing for the rest of the day. Not too bad. 1, 2, 3, 4 labs. So this will all be text-based labs, just because the vision labs can be a bit of a pain in the butt. So yeah, all this is going to be is our first dynamic one, so interactive, right? So Ollama interactive, this is the script. So basically what this is going to do is we're going to have this nice little while true loop. So we're going to have query, so basically a question. We're going to have the input function, query. Response equals the AI function in query. So we're going to send up the query to the AI function. If we look at the AI function, hey, look at that. We basically just copy and pasted what we had before, only we added an injection. So this is what we talk about with injections. So injection equals answer in under 20 words, so we can keep this thing simple. Then we're going to have query. So the query that comes in, query is going to equal an F string injection, and then hyphen hyphen query. This is nothing special. I just find separating this kind of thing by hyphen hyphen seems to work fine for me. One of the lessons that you're going to learn is dealing with these different models is there's something called prompt engineering. And so prompt engineering is more like very weird psychology than it is engineering, where you literally just ask the model the same question in 50 different ways and figure out what gives you the best response. So have fun with it. So anyways, so we're creating this F string. So basically say answer in under 20 words, whatever the query is. We come down here, basically exactly what we had before, response, granite 1B model, user, and now we have query. Do make sure it's not within the quotation marks because we're using the variable value. We're not putting in, so literally if you put quotation marks around query, it's going to respond to query, and you're going to get very weird responses back. Anyways, the return is then going to be this, response.message.content. Now, one of the things we're going to do is we're going to import the OS module up here, and this is to try to give a little bit better user experience. So as I said before, if you do os.thesystem function, this simply sends a command directly to your terminal, your command line. So if you're using a Linux or a Mac, you do clear, and this is going to clear the screen, right? If you use Windows, you're going to use CLS, because Windows is different. So what's going to happen is I'm going to put in my query. It's going to send that to the AI. When the response pack comes back, it'll clear the screen, and it'll print what the query is, and it'll print what the response is. So see, I've got the query. So initially it's down there, and I can say, what is a woodchuck? And then see how it clears the rest of the screen to make it a little bit easier. What is a woodchuck? A woodchuck is a burrowing rodent, also known as a groundhog, native to North America. Again, I can say, who was the Tsar of Russia in 1900? Oh, it actually answered. That was pretty quick. Anyways, before it gave me prompts, I don't know. Who was the first president of Russia? Okay, it's actually answering me. So anyways, so there we go. So it gives what the query is, and it gives what the response is. And so this gives us our first little interaction with an interactive AI system. So this is all through Python and working as it is. Any questions here? No? Cool. Okay, now we're going to go to the next one. So one of the big things that we need to be thinking about is when we start building our AI systems, right? Everybody wants artificial intelligence to care about them, right? I'm special. So one of the big problems you run into with an AI system, especially if you're dealing with Ollama, is if I say something like, who was my first president? Or I say, who was the president in 1970? Right, well, think about it. There's 300 countries in the world. Who the hell am I talking about? Right? Remember, like one of the issues with these AI systems is the false concept that they're intelligent. Because as soon as you say that they are intelligent, you start assuming a lot of things about the system that have nothing to do with reality, right? So it was interesting. The first time I taught a class here, back in November or whatever, the first class was AI with Ollama. And it was funny, like, because I was taking people through these kind of scripts, and everybody's like, oh, well, it remembers, doesn't it? And I'm like, we didn't build a memory system yet. Oh, it knows, doesn't it? No, we didn't build a system for it to know anything. But it was amazing how everybody, they assumed that it would know or remember, when it was like, no, we have not built those subsystems yet, so no, it doesn't, right? Every time I ask a question here, it is a brand new question to the system. It only knows the information that is actually on my computer. So if we go to the lab personalize, so we go to page 36, what this is going to do is it's going to add our REST API. So again, and this is how we start building these systems. Very simple things become much more complicated. So basically what we're going to be doing in this system is we are going to be taking the response that comes back from the IP-API.com JSON. So when we go to that REST API, we are going to be returning that entire response. The nice thing is, when I used to do these classes, LLMs aren't quite as good as they are now. So I actually had to pull out specific information. So I used to pull out city or country or whatever else and all this formatting and parsing stuff. What's kind of cool is these LLMs are now good enough. I just feed it the entire JSON response and let it deal with it. And so again, that's one of the things you have to be thinking about, like, where do you need to code? Where do you need to parse? And when can LLMs just deal with things? So anyways, basically if we take a look at this, the first thing that happens is we do location equals the geo function. So notice this happens outside the while true loop. Remember, whenever we hit APIs, REST APIs, two things that we have to worry about. One, how much is it going to cost us? And then two, the more we hammer the hell out of their API, the more likely they are to block us. Right? So again, if you want to hammer it a lot, that's fine. But think about a while true loop. If you're just hammering for no reason, right? So anyways, so we're going to be getting the geographic information before the while true loop starts. Why this is important is to think about the flow of the program. If I start this script and I change my location using a VPN, it will still have the initial location in here. So again, one of those things just to consider. So anyway, so we go up here, and again, if we take a look at it, it's exactly the same type of thing that we did before. We go to the URL, we do the request.get URL, we bring it back as a JSON value, we assign that to response, and then we simply return response, so we return that entire JSON value. We're then gonna go here, so query, again, we're going to ask a question. Response equals AI, so we're going to send query, and we're going to send our entire location. So we do send the location every single time we go to the AI, because every time we go to the AI, it's a brand new conversation as far as the AI is concerned. Again, we go up here, we take a look at it. So we have injection, answer, whoops. So we have answer in under 20 words. So that's the injection. So follow these instructions, the injection. I am located here, whatever the location is that came in. This is my question, and you give it the query. So again, the more you start to give the AI, the more you have to finagle this mess for it to actually give you the answer that you want. Anyways, same type of thing. It goes to Granite 4.1b. Here is our query. So the entire query then comes through, and then we respond with a response. We clear the screen, we print the query, we print the response. So if I do this, right, who was president in 1976? Who was? Anyways, Gerald Ford, right? Who was the first president? Right, Washington, right? Because it thinks I'm, in the United States. Now again, I kill this, I stop this, and then we go to our friends in Argentina. All right, now I run this again. So when I run this, it's now picking up the new location. Who was the president in 1976? Eduardo, whatever that is, right? So it's now giving me information dynamically based off of who I am. And so this is one of those things to be thinking about when you start building these systems Oh, for your company, like imagine you have employees that need to communicate with HR, right? And so you can tag your HR employees based off of what locations they support. And so one of the questions is where is this employee coming in from? So if you deal with something called Active Directory, I am an Active Directory fanboy. Anyways, part of Active Directory, there's a schema, there's a database system, so you can actually state the location of where employees are homed. And so literally, you could pull, since it's a database system, it's much more complicated this, but you could pull what their home location is, and when they say, who do I need to speak to about taking days off, it could then go, oh, you're from the Durham thing, here are the Durham human resources people, so you would talk with one of these folks, right? And so that, again, that's where we start talking about things like intelligence. Do we need a bigger frontier model to support that, or do we need better database systems, right? And again, one of the things you'll notice in the technology world is everybody likes to build servers and write code. Nobody likes to do documentation. And I think that's the real $1 billion value here, is whoever comes up with a good documentation company in the world of AI. I think that's going to be the big one. But anyways, so that's what's going on here with this. Any question on personalized AI? No? Cool. Okay, so then we're going to kill that, and we're going to go to memory. Right? Let's see here. Which one is this called? Ollama memory. Okay. So with this one, we're going to be adding memory too. So we have our same stuff up here, OS requests. We're going to have the geography thing, so we still get that customized thing based off of us. The curious thing down here, though, is we are going to, right after the location function call, we're going to do the with open. So with open, we're going to create memory. Memory.txt, W for overwrite as file, file.write. This is the conversation we have had. All right, so basically now we're going to say this is the conversation we're having, and we do /n/n. So we're doing the overwrite here, basically so that every time we start a new session, we get a new memory. When you want to see something really interesting and fun, start giving an AI system more and more memory. And it is interesting to see what it starts latching onto. And it might start latching onto things you don't expect. So clearing out the memory can be a useful thing. Again, that's one thing to be thinking about with these systems, is a thing of like how do you clean up the memory so that you actually start getting valuable responses back. Anyways, so basically with this, query, right? Input. Let's see here. So with open memory.txt, read memory equals file.read. So now we're going to have AI, the query, the location, and the memory. Now we go up to the AI function. Basically, same kind of thing we had before. Follow these instructions. We have the injection for 20 words. I am located here. That's the location that comes in. This is our conversation up until now. That's where we give the memory. And now here is my question. Right? Pretty simple. And then we come down, we print out, we clear the screen, we print out the query, we print out the response, and then we add the information to our memory. So we open memory.txt, append to add to the bottom as file, my query, and what the query was, /next line, your response /next line. So I just kind of gave it like a little gap. Again, you're trying to figure out what the hell the LLM is actually saying. So you just play with it. Like, should it be 2 ends or should it be 5? I don't know, play with it, see what happens. So anyways, what's really cool with this is I can run this now and I can say, who was my president in 1978? Right? Oh, Argentina. Anyways, I forgot I was in Argentina. Anyways, we should still get a response. And I can say, who was his wife? Now notice here, I'm not saying who is the wife of the president of Argentina. I'm saying who is his wife. Again, I don't think any of us know what the actual answer is, but anyways, yeah, so Nestor Kirchner, so that guy's wife was blah, 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 right? Then I can say, how old was she? Again, has memory. She was approximately 37 years old. How many kids did they have? Right, Nestor and Christina had 2 children together. Well, and I can say, what were their their names. This hasn't broken yet, which is kind of impressive. Blah, blah, had 2 children, Gabriella and Philippe, right? So again, now we can start interacting because it has that memory component to it. Not a lot to it. Again, this is where, so we use a file. So right now we're using memory.txt. Again, in the real world, you would actually use a database system for this to try to clean it up, but we're trying to keep this stuff simple. Any questions on memory? Yeah, cool, cool. Okay, then we got the last one, and then you guys get to type for the rest of the day. So we're going to create an auto blog. Where is my auto blog? Yeah. So basically what this auto blog is going to do is it's going to show you why the internet is about to die really soon. Because basically, so what we're going to do is we're going to use something called the Beautiful Soup module. Again, when you want to add functionality to your Python code, go out and find a module for it. There probably exists. So what Beautiful Soup does is it allows you to scrape websites, because the problem that you run into is you can use the request module to simply get an entire website or entire web page. The issue they're going to deal with is you're also going to get all of the JavaScript, all of the CSS, all of the XML, everything that goes around the text you want. Right? So think about this. So back in the day, I wasn't thinking about this, so I tried to submit an entire web page to OpenAI. Literally, if you just get the words from a page, so like a normal Ars Technica article will be about 600 words. It's 1,000 tokens is about 750 words. So if you get an entire page from Ars Technica, it'll be about 1,000 tokens for the page, and then maybe 1,000 tokens for a response, so about 2,000 tokens. If you grab an entire page, especially with a modern CMS, content management system, there is so much JavaScript and everything else. Literally, I was clocking 60,000 tokens just to ingest. So you go from 1,000 tokens to 60,000 tokens. The other thing too, again, when we start talking about building these AI systems and I talk about architecture, is even if you have your server, let's say you have your server and you have got a $40,000 GPU on it, right? Remember, you need to be thinking about how much data you actually need to send to these LLMs. So if you're sending 60,000 tokens to an LLM when all you really needed is to send 1,000 tokens to the LLM, right? That's really just beating the hell out of your systems for no good reason, right? Again, 10 lines of code can decrease the amount of tokens by just a massive degree. So anyways, so let's go take a look at this. So when we do this, I guess I'll run it for the first time. So we got a while true loop. So I'm going to run this. Okay, so it's going to ask me for a URL. I am going to go to Gizmodo. Come on, Gizmodo. Should I invest in SpaceX? In a sane world, no, but we are not in a sane world. Anyways, okay, so all I did there is I grabbed the URL. So I just copied the URL. I can go back to my VS Code, and then I can hit V. So all I'm doing is pasting the URL in there, and then I'm hitting enter. Bum, ba-bum, ba-bum, bum, bum. So the 2 things it's going to do for me, because I want unique, is it's going to create a brand new blog post for me, and it's also going to create a title for me. Wow, created a long article there. So title, should you invest in SpaceX's IPO? An in-depth analysis. And here's all the text. The cool part is we can now go to our auto blog, reveal in Finder. We double click on auto blog, and there we go. No, oh, it's at the bottom because we're appending. Anyways, so there we go, that quick. SpaceX IPO, should I invest? Should you invest in SpaceX's IPO? An in-depth analysis. SpaceX, the brainchild visionary entrepreneur Elon Musk, has revolutionized space industry with its innovative technology and ambitious projects as a privately held company, blase, blase, blase. So think about this. This is a 1 billion parameter model that was able to take this information and was able to create this quick. So this isn't even like GPT OSS, again, OpenAI's model will do a much better version of this. But again, with a 1 billion parameter model, it works this well. Why this gets really scary, and why, again, I do think the normal web is going to die pretty soon, is we did a web scraping class, I don't know, in November, I think it was. And one of the curious things is you can connect this to something called feed parser. So what I can do is I can take all the technical websites out there, so Gizmodo, Ars Technica, Engadget, all of them, they all have this thing called an RSS feed. In that RSS feed is links to all of their current articles that get updated in real time. So I can literally have feed parser come through, create a list of all the current links, and then literally with a database system, I can then take that link, basically grab the text, auto create a blog post, and then just constantly do that as quickly as those companies are producing their own blog posts. And so again, that's the kind of thing to think about. Like, you know, before, one of the problems in the content business was you have all these folks in Bangladesh. And so you have like a warehouse in Bangladesh where you have 5 people or 500 people all typing away to create blog posts. And now imagine if 500 of those people, and each one of them can create 100 blogs a day. Like, we're just going to create 20 entire blogs with you know, 5,000 posts and the whole 9 yards per day. And especially with all this too, this is all very simple here because I'm just trying to show you the simple concept. Using a image creation tool like DALL-E from OpenAI, but you can also get local. Like you literally, you can grab all of this, you can then grab the title, you can ask it to then create an image for this, and with a little bit of additional formatting with CSS and the rest of it, you can have a professional looking blog that just is ripping off everybody, right? So, anyways. So we take a look at this. It's all pretty simple.
That's almost as much effort as being a commentary channel.
Yeah. So we have the same stuff. So from BS4, import Beautiful Soup. So we will need to install the Beautiful Soup module. So we have that there. Pip install Beautiful Soup 4. Basically, we come down here. So we have the while true loop. So here's where we input our URL. Next, we are then going to scrape the URL. So this is where we go to Beautiful Soup. So text equals scrape the URL. And that's where we go here. You don't really have to understand a lot of this at this point, but basically what we do is request.getURL, and then we bring this back as text. We're not bringing it back as JSON, we're bringing it back as text. Then we use soup equals the Beautiful Soup function, page, and then HTML parser. So they actually have a number of different parsers, and so what these parsers do is they essentially read the document to kind of figure out what it is. HTML parser, just leave it as that. And then so what we do here is paragraphs equals soup.findAll as basically anything within the p tag. So anytime there's a p tag, it's going to grab all of that text and it's going to put it into a list. So the first p tag is index 0, second index 1, so on and so forth. Then what we're going to do here is page text equals nothing. For line in paragraphs, so again, this is a list of all those p tags. Page text plus equals, like we've done before, line.text. So what this .text does is it simply rips the text out, so you leave all the tags and all the CSS behind, and you just get our nice pure text. We are then going to return all of that text back. Past that, we're then going to have a query. So write a 200-word blog post about this text. And again, tell it what the hell you want, because it will go on forever if you want. And so what we do here is we do response post equals post query. So we're going to send this query up to the post, and this is what's actually going to give us our blog post. Anyways, all the same stuff that we had before, and then we're going to return the value back. Then what we're going to do down here is we are going to say response title equals title.text. So basically, we want a new title too. Again, we're worried about copyright. Like if I steal from you, I don't want to be sued for that. So what I'm going to do is I'm going to take all that text, I'm then going to feed that to a title function. And we come up here to the title function, and it basically says create a 10-word title for this post. Right? That value comes in, that's for the query, and then we get the response back. Then basically we print out the response title, and we print out the response post. We put this little line there so we know what's going on. And so with open autoblog.htm, we're going to append, we're going to add to, as file, file.write, h1, the response title, p tag, the response post, and that's going to give us what I showed you folks. And that's about it. Any questions on autoblogs? No? Cool. See? Yeah. And again, like with a little bit of additional thing, like with next line and things. So like here, like you'll notice, like this is all this kind of block. Basically, with a little bit of additional code, we could then rewrap all of these into its own individual p tags so the paragraphs look properly. So you can actually write code so this gets formatted so it looks much better. Yeah.
I have a specific question on my computer. I'm having issues with importing Ollama.
Okay.
I see a basic Ollama, but I don't think that's the same as the regular Ollama.
Okay, we'll get to you in a second. Any questions on any of the labs up until this point? No? Cool. Okay, so we have this place till 5. So you have an hour and 40 minutes to lab away, and I'll help you out. You have a question? Yep.
Where would the P tabs go?
What's that?
Where would the P tabs go if you said you wanted to format that out?
Okay, so what you would do is where there's next line. So where did my...
If I do that, and then
What happens here is.
Yeah, that's all p tags. Oh, where would I do that?
Or the so, or actually.
The text that comes back.
So you've got different Python installs on here. What were you choosing to run into?
So what I would do...
Right now you're in global. Try clicking in.
So here, I'm going to try this.
Install it
Uh,
again. There's two environments in there. And you're installing Ollama into one and you're calling the other. It's funky.
equals...
So if you see there that Python that you're in, just do Python enter. This is that tablet bullshit. So see your 314.2. So if you hit open up like PowerShell or command prompt,
For...
and then just go on type in the same thing, just Python. Python like just say enter, just Python enter. So you should be in the same. So X down there, try installing Ollama in there. It's annoying to figure out what that exact thing is.
And then you would do file right. Oh, up. Let's see.
One of those two environments is what she and I were given.
Oops, are you leaving? Oh, yeah.
You don't do that command there. That's not a
finally picked it up. Finally.
on the outside.
Oh.
Finally picked it up.
So you
What
got
was it trying, all your Ollama?
Yeah, I couldn't get Ollama there.
Okay. Veronica. Okay. So same article I did. See how this is now within p tags? Okay, so basically what that is, oops,
just got your little set.
is so what happens is I take that response post that I got back, and then I split it. So again, I turn it into a list based off of wherever there's a next line. Right, so wherever there's a next line, I split it. So index 0 is the first line, index 1, right? And then I create post HTML, I make that blank. And then I say for line in response post, so each line, post HTML plus equals f string, do the p tag, put that line, close the p tag. And so basically that's going to be all HTML formatted now. And then I write that to the page. Oh, yeah. Yeah.